Demi terwujudnya sumber daya manusia yang ahli di bidang perkeretaapian yang berstandar internasional, Politeknik Perkeretaapian Indonesia Madiun juga menyediakan ruang simulator dan laboratorium dengan dukungan teknologi terkini, seperti laboratorium komputer, laboratorium CBI, laboratorium persinyalan mekanik dan CTC, simulator KRD, simulator lokomotif, ruang coil spring test, bugi load test, kereta latih, serta klinik PPI Medika.
Politeknik Perkeretaapian Indonesia Madiun memiliki fasilitas pembelajaran yang lengkap dan modern, sehingga dapat menunjang pembelajaran para taruna dan taruni.
Ratusan prestasi baik akademik dan non-akademik berhasil diraih oleh taruna-taruni Politeknik Perkeretaapian Indonesia Madiun berkat kedisiplinan serta semangat pantang menyerah yang selalu diunggulkan di kampus PPI Madiun. Prestasi-prestasi tersebut diantaranya juara 1 speech contest, juara 2 English presentation, dan juara 3 newscasting pada Indonesian Transportation English Olympic 2021. Peringkat 1, 2, dan 3 untuk kategori Vocational Student Best Paper pada Forum Studi Transportasi Antar Perguruan Tinggi 2020. Peringkat 1 Best Presenter Vocational Program dan peringkat 2 Best Presenter Undergraduate Program pada Forum Studi Transportasi Antar Perguruan Tinggi 2019. Peringkat 1, 2, dan 3 untuk penyaji makalah terbaik kategori vokasi pada Forum Studi Transportasi Antar Perguruan Tinggi 2018. Dan masih banyak prestasi lainnya. Kampus Politeknik Perkeretaapian Indonesia Madiun berkomitmen untuk menghasilkan lulusan yang mempunyai pengetahuan, pemahaman, dan kecakapan di bidang perkeretaapian serta memiliki integritas profesionalisme yang tinggi dan berbudi pekerti luhur. Dengan perkembangan jaringan dan teknologi perkeretaapian di Indonesia, PPI Madiun terus bertumbuh dan mengembangkan diri menjadi rujukan perguruan tinggi regional atau internasional dengan program-program strategis, di antaranya perolehan akreditasi internasional, dosen berkualitas yang diakui secara internasional, peningkatan kerjasama dengan lembaga luar negeri di bidang perkeretaapian, dan pengembangan program studi sesuai dengan kebutuhan stakeholder di bidang perkeretaapian.
Politeknik Perkeretaapian Indonesia Madiun siap mencetak sumber daya manusia yang prima, profesional, dan beretika.
Besarnya mobilitas masyarakat Indonesia saat ini menuntut sarana dan prasarana transportasi yang memadai untuk mendukung aktivitas yang serba cepat. Salah satunya adalah industri perkeretaapian yang saat ini sudah berkembang pesat baik dari teknologi maupun sumber daya manusianya. Hal tersebut menuntut kesiapan sumber daya perkeretaapian harus bisa menjawabnya. Dan peran pemerintah dalam menciptakan sumber daya manusia yang berkualitas, profesional, dan modern di industri perkeretaapian dapat diwujudkan melalui institusi pendidikan Politeknik Perkeretaapian Indonesia Madiun. Politeknik Perkeretaapian Indonesia atau PPI adalah perguruan tinggi kedinasan yang berdiri pada tahun 2012 di Kota Madiun, Jawa Timur, di bawah naungan Badan Pengembangan SDM Perhubungan Darat, Kementerian Perhubungan Republik Indonesia. Dan tepat pada tahun 2019, Akademi Perkeretaapian Indonesia berubah menjadi Politeknik Perkeretaapian Indonesia Madiun. PPI Madiun memiliki visi yaitu menjadi pusat unggulan dan inovasi pendidikan serta pelatihan vokasi di bidang teknis perkeretaapian berbasis teknologi global pada tahun 2030. Selain itu, PPI Madiun juga mengemban misi, yaitu mewujudkan lembaga pendidikan dan pelatihan tinggi yang unggul, transparan dan akuntabel, menyelenggarakan dan mengembangkan pendidikan dan pelatihan vokasi yang berbasis kompetensi dan perkembangan teknologi perkeretaapian, serta mengintegrasikan pembelajaran kepribadian yang prima, profesional dan beretika. mengembangkan ilmu pengetahuan dan teknologi melalui penelitian terapan di bidang teknis perkeretaapian serta berdaya saing secara global, melaksanakan pengabdian masyarakat melalui penerapan teknologi tepat guna untuk meningkatkan keselamatan penyelenggaraan transportasi perkeretaapian dan menjalin kerjasama dengan berbagai institusi, baik di dalam maupun di luar subsektor perkeretaapian dalam rangka pembangunan sumber daya manusia. Berdiri di atas lahan seluas kurang lebih 18 hektar, PPI Madiun tidak hanya melahirkan SDM perkeretaapian dari aspek kuantitas, tetapi juga aspek kualitas. Karena lulusan PPI Madiun tidak hanya terjun mengabdi di pemerintahan saja, tetapi juga perusahaan-perusahaan bidang perkeretaapian nasional maupun internasional. Sehingga lulusan PPI Madiun nantinya bisa berkiprah di tingkat global. Dan untuk melahirkan lulusan dengan keahlian standar global, PPI Madiun mempersiapkan SDM dengan baik dari sisi tenaga pengajar maupun dari sisi taruna dan taruni. Politeknik Perkeretaapian Indonesia Madiun memiliki beberapa program studi, di antaranya Teknologi Elektro Perkeretaapian, Teknologi Bangunan dan Jalur Perkeretaapian, Teknologi Mekanika Perkeretaapian, dan Manajemen Transportasi Perkeretaapian. Dalam perkuliahan, Politeknik Perkeretaapian lebih banyak melakukan pembelajaran dalam bentuk praktek agar taruna dan taruni lebih memahami teknis dalam dunia perkeretaapian dan siap terjun di dunia kerja.
Politeknik Perkeretaapian Indonesia Madiun adalah sekolah kedinasan di bawah naungan BPSDM Perhubungan Darat yang mencetak SDM perkeretaapian yang unggul dan juga berkualitas.
Untuk mendukung kegiatan belajar mengajar para taruna, taruni, dan staf pengajar, Politeknik Perkeretaapian Indonesia Madiun dilengkapi dengan fasilitas dan sarana prasarana yang modern dan memadai, seperti asrama eksekutif, ruang kelas, ruang dosen, perpustakaan, career center, sport hall, ruang batalion, ruang makan, dan masjid. Demi terwujudnya sumber daya manusia yang ahli di bidang perkeretaapian yang berstandar internasional, Politeknik Perkeretaapian Indonesia Madiun juga menyediakan ruang simulator dan laboratorium dengan dukungan teknologi terkini, seperti laboratorium komputer, laboratorium CBI, laboratorium persinyalan mekanik dan CTC, simulator KRD, simulator lokomotif, ruang coil spring test, bugi load test, kereta latih, serta klinik PPI Medika.
Politeknik Perkeretaapian Indonesia Madiun memiliki fasilitas pembelajaran yang lengkap dan modern, sehingga dapat menunjang pembelajaran para taruna dan taruni.
Ratusan prestasi baik akademik dan non-akademik berhasil diraih oleh taruna-taruni Politeknik Perkeretaapian Indonesia Madiun berkat kedisiplinan serta semangat pantang menyerah yang selalu diunggulkan di kampus PPI Madiun. Prestasi-prestasi tersebut diantaranya juara 1 speech contest, juara 2 English presentation, dan juara 3 newscasting pada Indonesian Transportation English Olympic 2021. Peringkat 1, 2, dan 3 untuk kategori Vocational Student Best Paper pada Forum Studi Transportasi Antar Perguruan Tinggi 2020. Peringkat 1 Best Presenter Vocational Program dan peringkat 2 Best Presenter Undergraduate Program pada Forum Studi Transportasi Antar Perguruan Tinggi 2019. Peringkat 1, 2, dan 3 untuk penyaji makalah terbaik kategori vokasi pada Forum Studi Transportasi Antar Perguruan Tinggi 2018. Dan masih banyak prestasi lainnya. Kampus Politeknik Perkeretaapian Indonesia Madiun berkomitmen untuk menghasilkan lulusan yang mempunyai pengetahuan, pemahaman, dan kecakapan di bidang perkeretaapian serta memiliki integritas profesionalisme yang tinggi dan berbudi pekerti luhur. Dengan perkembangan jaringan dan teknologi perkeretaapian di Indonesia, PPI Madiun terus bertumbuh dan mengembangkan diri menjadi rujukan perguruan tinggi regional atau internasional dengan program-program strategis, di antaranya perolehan akreditasi internasional, dosen berkualitas yang diakui secara internasional, peningkatan kerjasama dengan lembaga luar negeri di bidang perkeretaapian, dan pengembangan program studi sesuai dengan kebutuhan stakeholder di bidang perkeretaapian.
Politeknik Perkeretaapian Indonesia Madiun siap mencetak sumber daya manusia yang prima, profesional, dan beretika.
Besarnya mobilitas masyarakat Indonesia saat ini menuntut sarana dan prasarana transportasi yang memadai untuk mendukung aktivitas yang serba cepat. Salah satunya adalah industri perkeretaapian yang saat ini sudah berkembang pesat baik dari teknologi maupun sumber daya manusianya. Hal tersebut menuntut kesiapan sumber daya perkeretaapian harus bisa menjawabnya. Dan peran pemerintah dalam menciptakan sumber daya manusia yang berkualitas, profesional, dan modern di industri perkeretaapian dapat diwujudkan melalui institusi pendidikan Politeknik Perkeretaapian Indonesia Madiun. Politeknik Perkeretaapian Indonesia atau PPI adalah perguruan tinggi kedinasan yang berdiri pada tahun 2012 di Kota Madiun, Jawa Timur, di bawah naungan Badan Pengembangan SDM Perhubungan Darat, Kementerian Perhubungan Republik Indonesia. Dan tepat pada tahun 2019, Akademi Perkeretaapian Indonesia berubah menjadi Politeknik Perkeretaapian Indonesia Madiun. PPI Madiun memiliki visi yaitu menjadi pusat unggulan dan inovasi pendidikan serta pelatihan vokasi di bidang teknis perkeretaapian berbasis teknologi global pada tahun 2030. Selain itu, PPI Madiun juga mengemban misi, yaitu mewujudkan lembaga pendidikan dan pelatihan tinggi yang unggul, transparan dan akuntabel, menyelenggarakan dan mengembangkan pendidikan dan pelatihan vokasi yang berbasis kompetensi dan perkembangan teknologi perkeretaapian, serta mengintegrasikan pembelajaran kepribadian yang prima, profesional dan beretika. Mengembangkan ilmu pengetahuan dan teknologi melalui penelitian terapan di bidang teknis perkeretaapian serta berdaya saing secara global, melaksanakan pengabdian masyarakat melalui penerapan teknologi tepat guna untuk meningkatkan keselamatan penyelenggaraan transportasi perkeretaapian dan menjalin kerjasama dengan berbagai institusi, baik di dalam maupun di luar subsektor perkeretaapian dalam rangka pembangunan sumber daya manusia. Berdiri di atas lahan seluas kurang lebih 18 hektar, PPI Madiun tidak hanya melahirkan SDM perkeretaapian dari aspek kuantitas, tetapi juga aspek kualitas. Karena lulusan PPI Madiun tidak hanya terjun mengabdi di pemerintahan saja, tetapi juga perusahaan-perusahaan bidang perkeretaapian nasional maupun internasional. Sehingga lulusan PPI Madiun nantinya bisa berkiprah di tingkat global. Dan untuk melahirkan lulusan dengan keahlian standar global, PPI Madiun mempersiapkan SDM dengan baik dari sisi tenaga pengajar maupun dari sisi taruna dan taruni. Politeknik Perkeretaapian Indonesia Madiun memiliki beberapa program studi, di antaranya Teknologi Elektro Perkeretaapian, Teknologi Bangunan dan Jalur Perkeretaapian, Teknologi Mekanika Perkeretaapian, dan Manajemen Transportasi Perkeretaapian. Dalam perkuliahan, Politeknik Perkeretaapian lebih banyak melakukan pembelajaran dalam bentuk praktek agar taruna dan taruni lebih memahami teknis dalam dunia perkeretaapian dan siap terjun di dunia kerja.
Politeknik Perkeretaapian Indonesia Madiun adalah sekolah kedinasan di bawah naungan BPSDM Perhubungan Darat yang mencetak SDM perkeretaapian yang unggul dan juga berkualitas.
Untuk mendukung kegiatan belajar mengajar para taruna, taruni, dan staf pengajar, Politeknik Perkeretaapian Indonesia Madiun dilengkapi dengan fasilitas dan sarana prasarana yang modern dan memadai, seperti asrama eksekutif, ruang kelas, ruang dosen, perpustakaan, career center, sport hall, ruang batalion, ruang makan, dan masjid. Demi terwujudnya sumber daya manusia yang ahli di bidang perkeretaapian yang berstandar internasional, Politeknik Perkeretaapian Indonesia Madiun juga menyediakan ruang simulator dan laboratorium dengan dukungan teknologi terkini, seperti laboratorium komputer, laboratorium CBI, laboratorium persinyalan mekanik dan CTC, simulator KRD, simulator lokomotif, ruang coil spring test, buki load test, kereta latih, serta klinik PPI Medika.
Politeknik Kereta Apian Indonesia Madiun memiliki fasilitas pembelajaran yang lengkap dan modern, sehingga dapat menunjang pembelajaran para taruna dan taruni.
Ratusan prestasi baik akademik dan non-akademik berhasil diraih oleh taruna-taruni Politeknik Perkeretaapian Indonesia Madiun berkat kedisiplinan serta semangat pantang menyerah yang selalu diunggulkan di kampus PPI Madiun. Prestasi-prestasi tersebut diantaranya juara 1 speech contest, juara 2 English presentation, dan juara 3 newscasting pada Indonesian Transportation English Olympic 2021. Peringkat 1, 2, dan 3 untuk kategori Vocational Student Best Paper pada Forum Studi Transportasi Antar Perguruan Tinggi 2020. Peringkat 1 Best Presenter Vocational Program dan peringkat 2 Best Presenter Undergraduate Program pada Forum Studi Transportasi Antar Perguruan Tinggi 2019. Peringkat 1, 2, dan 3 untuk penyaji makalah terbaik kategori vokasi pada Forum Studi Transportasi Antar Perguruan Tinggi 2018. Dan masih banyak prestasi lainnya. Kampus Politeknik Perkeretaapian Indonesia Madiun berkomitmen untuk menghasilkan lulusan yang mempunyai pengetahuan, pemahaman, dan kecakapan di bidang perkeretaapian serta memiliki integritas profesionalisme yang tinggi dan berbudi pekerti luhur. Dengan perkembangan jaringan dan teknologi perkeretaapian di Indonesia, PPI Madiun terus bertumbuh dan mengembangkan diri menjadi rujukan perguruan tinggi regional atau internasional dengan program-program strategis, di antaranya perolehan akreditasi internasional, dosen berkualitas yang diakui secara internasional, peningkatan kerjasama dengan lembaga luar negeri di bidang perkeretaapian, dan pengembangan program studi sesuai dengan kebutuhan stakeholder di bidang perkeretaapian.
Politeknik Perkeretaapian Indonesia Madiun siap mencetak sumber daya manusia yang prima, profesional, dan beretika.
Besarnya mobilitas masyarakat Indonesia saat ini menuntut sarana dan prasarana transportasi yang memadai untuk mendukung aktivitas yang serba cepat. Salah satunya adalah industri perkeretaapian yang saat ini sudah berkembang pesat baik dari teknologi maupun sumber daya manusianya. Hal tersebut menuntut kesiapan sumber daya perkeretaapian harus bisa menjawabnya, dan peran pemerintah dalam menciptakan sumber daya manusia yang berkualitas, profesional, dan modern.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang para hadirin. Perkenalkan, saya Irse Indonesia bersama rekan saya Mada Hernanda. Hari ini adalah kesempatan yang luar biasa dan berharga bagi kami untuk menjadi Master of Ceremony pada acara besar webinar Irse Indonesia Section Series 4 29 Juni 2022 dengan tema Cbtc Integration and Operation.
Good afternoon, ladies and gentlemen. My name is Moderator, and this is my colleague Irse Indonesia. It is a wonderful and precious chance for us to be your Master of Ceremony in this great event of webinar Irse Indonesia Section Series 4 29th of June 2022 with the theme Cbtc Integration and Operation.
Di saat yang indah ini, kami ingin mengucapkan selamat datang kepada Bapak Arif Darmawan, selaku Ketua Penyelenggara Webinar Irse Indonesia Section Series 4, Cbtc Integration and Operation. Yang terhormat Dr. Yuwono Wiarco, S.SiT MT, selaku Direktur Politeknik Perkeretaapian Indonesia Madiun. Yang terhormat Bapak Agung Darmawan, selaku Ketua Irse Indonesia Section, dan yang terhormat Bapak Yanto Yulianto dari MRT Jakarta, serta Mr. Robert Cooke dari Land Transport Authority Singapore, sekaligus Ketua Irse Singapore Section, yang akan menjadi pembicara kita pada hari ini.
In this beautiful moment, we would like to welcome Mr. Arif Darmawan, the Chairman of the Webinar Committee, the Honorable Mr. Dr. Yuwono Wiarco, the Director of Indonesia Railway Polytechnic, the Honorable Mr. Agung Darmawan, the Chairman of Irse Indonesia Section, the Honorable Mr. Yulianto from MRT Jakarta, who will be our speaker today. Last but not least, the Honorable Mr. Robert Cooke from Land Transport Authority Singapore and the Chairman of Irse Singapore Section, who will be our speaker today.
Baik, hadirin yang berbahagia, sebelum kita memulai acara hari ini, marilah kita bersama-sama berdoa kepada Allah Subhanahu wa Ta'ala untuk menjadikan acara ini bermanfaat untuk kita semua, serta acara ini dapat berjalan dengan lancar serta kondusif.
Ladies and gentlemen, before we begin this event, let us pray together. The Almighty God make this event beneficial for us, and this event can run smoothly and conducively. Start praying. Finished.
Baik, acara selanjutnya menyanyikan lagu Indonesia Raya. Kepada yang bertugas, kami persilahkan. Baik, pada event yang istimewa ini kami memiliki beberapa agenda, oleh karena itu izinkanlah kami untuk membacakan susunan acara sebagai berikut. Yang pertama adalah pembukaan, yang kedua menyanyikan lagu Indonesia Raya, yang ketiga adalah sambutan oleh Bapak Arif Darmawan selaku Ketua Penyelenggara Webinar Irse Indonesia Section Series 4, Cbtc Integration and Operation, yang keempat adalah sesi foto, yang kelima adalah Keynote Speaker oleh Bapak Dr. Yuwono Wiarco selaku Direktur Politeknik Perkeretaapian Indonesia Madiun. Yang keenam adalah sambutan oleh Bapak Agung Darmawan selaku Ketua Irse Indonesia Section. Dan yang ketujuh adalah acara inti webinar Irse Indonesia Section Series 4 Cbtc Integration and Operation yang akan dimoderatori oleh Bapak Kristanto Usman. Dan yang terakhir adalah doa serta penutup.
On this special event, we have several agendas, so allow us to read several sequences of our agenda. The first is the opening, which we have previously had read together. The second is the opening speech by Mr. Arif Darmawan as the chairman of the webinar committee. The third agenda is photo session. The fourth agenda is keynote speaker by Mr. Dr. Yuwono Wiarco as the director of the Indonesian Railway Polytechnic. The fifth agenda is speech by Mr. Agung Darmawan, the chairman of Irse Indonesia section. The sixth is the main event seminar about Cbtc integration conducted by our moderator, Mr. Kristanto Usman. The last is the closing and prayer.
Baik, tanpa berlama-lama lagi, marilah kita beranjak ke acara selanjutnya. Sambutan oleh Bapak Arif Darmawan, selaku Ketua Penyelenggara Webinar Irse Indonesia Section Series 4, Cbtc, Integration and Operation. Kepada Bapak Arif Darmawan, kami persilahkan.
Bismillahirrahmanirrahim. Sambutan dan laporan Ketua Pelaksana pada webinar Institution Railway Signaling Engineer seri 4 dengan tema Cbtc Integration and Operation, Rabu 29 Juni 2022. Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Bapak Direktur Politeknik Perkeretaapian Indonesia, Bapak Chairman Irse Indonesian Section, Bapak Ibu, para pembicara dan moderator yang saya hormati, dan para peserta webinar dan hadirin sekalian yang saya banggakan. Pertama-tama marilah kita panjatkan puji syukur kehadirat Allah Subhanahu wa taala, Tuhan yang Maha Pengasih dan Penyayang, karena atas izinnya pada hari ini kita dapat berkumpul di sini untuk bersama-sama mengikuti acara webinar Irse seri 4 dengan tema Cbtc Integration and Operation. Latar belakang pemilihan tema tersebut terkait dengan semakin pesat perkembangan teknologi Cbtc dalam pengoperasian perkeretaapian untuk perkotaan baik di MRT, APMS, Bandara Soekarno-Hatta, dan LRT Jabodebek. Dalam sistem Cbtc, terdapat banyak elemen, seperti yang tercantum pada standar IEEE 14741, dan elemen tersebut harus terintegrasi dengan baik, sehingga dapat tercipta sistem yang aman dan selamat untuk pengoperasian kereta api perkotaan. Sehingga pada kesempatan ini, kami menghadirkan dua orang narasumber sebagai pembicara, yaitu Mr. Robert Cooke dengan topik Why QF4 It's a lot more than a signaling system in the Singapore perspective. Dan Mr. Yanto Yulianto dari MRT Jakarta dengan topik Pre-Orientation Signaling and Rolling Stock Integration, yang masing-masing akan membagikan materi dan pengalamannya. Webinar ini dapat terselenggara berkat bantuan dari berbagai pihak. Untuk karena itu, pada kesempatan ini, izinkan kami mengucapkan terima kasih yang sebesar-besarnya kepada Direktorat Jenderal Perkeretaapian, Bapak Direktur Politeknik Perkeretaapian Indonesia Madiun, Bapak Chairman Irse Indonesian Section beserta jajarannya, serta para sponsor yang telah berpartisipasi dalam kegiatan webinar ini. Penghargaan yang setinggi-tingginya juga kami sampaikan kepada segenap panitia yang bekerja keras demi suksesnya kegiatan webinar ini. Kami menyadari bahwa penyelenggaraan webinar ini masih banyak kekurangan baik dalam penyajian acara maupun keterbatasan fasilitas. Untuk itu, kami mohon maaf yang sebesar-besarnya. Akhir kata, semoga semua peserta webinar yang hadir dapat memanfaatkan manfaat yang sebesar-besarnya dari kegiatan webinar ini. Waalaikumsalam warahmatullahi wabarakatuh. Madiun 29 Juni 2022, Ketua Pelaksana Arif Darmawan.
Baik, terima kasih kami sampaikan atas sambutan yang luar biasa. Acara selanjutnya adalah sesi dokumentasi. Kepada para hadirin dimohon mengaktifkan kamera dan memposisikan diri untuk berfoto bersama.
Before getting to the next agenda, we would like to take a photo session for documentation. Ladies and gentlemen, Please make a position facing the camera. Firstly, we would like to take a first page. Thank you. Now for the second page. And then we're going to have the third page. Thank you.
Baik, acara selanjutnya adalah keynote speaker oleh Bapak Dr. Yuwono Wiarco selaku Direktur Politeknik Perkeretaapian Indonesia Madiun. Kepada Bapak Yuwono Wiarco, saya persilahkan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Selamat siang, salam sejahtera bagi kita semuanya. Yang kami hormati Bapak Direktur Pelaksana Perkeretaapian atau yang mewakili, yang terhormat Chairman Irse Indonesian Section, yang terhormat para pembicara, serta Bapak dan Ibu hadirin yang berbahagia. Pertama-tama, marilah kita panjatkan puji syukur kehadirat Allah Subhanahu wa Ta'ala, karena atas rahmat dan hidayahnya kita dapat hadir bersama pada hari ini dalam webinar Irse seri 4 dengan tema Cbtc Integration and Operation. Pertama, perkenankan saya menyampaikan apresiasi sebesar-besarnya kepada Irse Indonesian Section yang secara konsisten dan berkelanjutan memberikan sharing knowledge kepada anggota dan masyarakat secara luas mengenai teknologi persinyalan perkeretaapian. Hadirin yang terhormat, dalam beberapa tahun terakhir, teknologi persinyalan berkembang sangat pesat. Dengan pengoperasian kereta otomatis, dengan menggunakan tingkatan kontrol GOA2 dan GOA3, dengan sistem Cbtc, Communication Based Train Control, tentunya harus didukung oleh SDM yang kompeten dan handal di bidangnya. Politeknik Perkeretaapian Indonesia sebagai kampus bidang perkeretaapian mempunyai peran dalam penyiapan SDM tersebut, di mana PPI Madiun menyelenggarakan 4 program studi, yaitu Teknologi Bangunan dan Jalur Perkeretaapian, Program Studi Teknologi Mekanika Perkeretaapian, Program Studi Teknologi Elektro Perkeretaapian, dan Program Studi Manajemen Transportasi Perkeretaapian. Dalam penyiapan SDM, tentunya harus didukung oleh kurikulum dan silabus yang sangat memadai dan terkini, serta ditunjang sarana dan prasarana yang memadai. Dalam penyampaian materi juga harus ditunjang oleh pengajar yang memadai. Hal tersebut adalah tantangan yang harus dihadapi dalam penyiapan SDM. Sinergi antara organisasi profesi dan unsur akademisi merupakan salah satu bentuk implementasi yang sangat bagus dalam penyiapan SDM melalui beberapa kegiatan antara lain sharing knowledge, joint research, dan pelaksanaan program magang industri. Akhir kata, saya Yuwono Wiarco selaku Direktur PPI Madiun sekali lagi menyampaikan terima kasih kepada Irse Indonesia dan semua pihak yang mendukung acara webinar ini. Demikian yang dapat kami sampaikan. Terima kasih atas perhatian Bapak, Ibu, dan saudara sekalian. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Baik, terima kasih atas keynote yang telah disampaikan. Berikutnya, sambutan oleh Bapak Agung Darmawan, selaku Ketua Irse Indonesian Section. Kepada Bapak Agung Darmawan, kami persilahkan.
The fifth agenda is speech by Mr. Agung Darmawan as the chairman of Irse Indonesia section. For Mr. Agung Darmawan, please be on the stage. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera untuk kita semua. Yang terhormat Bapak Yuwono Wiarco, Direktur PPI, yang terhormat Bapak Darmawan selaku Ketua Panitia, yang terhormat adik-adik taruna-taruni PPI, ini luar biasa sekali, yang terhormat juga rekan-rekan pengurus Irse dan segenap anggota Irse Indonesia Section, dan juga peserta seminar dari berbagai institusi dan komunitas perkeretaapian Indonesia. Puji syukur, alhamdulillah, acara webinar bulanan Irse bisa kita selenggarakan lagi hari ini. Dan pada webinar Irse kali ini kita mengangkat topik Cbtc Integration and Operation, yang mana topik ini sangat relevan dengan apa yang sedang kita hadapi sekarang, yaitu isu seputar operasi sistem Cbtc, baik yang sudah ada dan juga isu rencana integrasi
Baik, mungkin Bapak Agung Darmawan sedang terkendala jaringan. Setelah ini kita akan menuju ke agenda berikutnya.
Halo, sudah terhubung? Baik, saya ulangi lagi. Pertama, kami sampaikan salam sejahtera buat kita semua, Pak Yuwono, Direktur PPI yang terhormat, dan Pak Arif Darmawan, selaku Ketua Panitia, juga adik-adik taruna-taruni PPI, rekan-rekan pengurus Irse dan segenap anggota Irse Indonesia Section, juga berbagai peserta seminar dari berbagai institusi dan komunitas perkeretaapian Indonesia. Syukur alhamdulillah acara webinar bulanan Irse bisa kita selenggarakan lagi pada hari ini. Dan webinar kali ini mengangkat isu Cbtc Integration and Operation, yang mana topik ini sangat relevan dengan apa yang sedang kita hadapi sekarang, yaitu isu-isu seputar operasi sistem Cbtc yang sudah ada dan rencana integrasi sistem Cbtc pada LRT Jabodetabek yang saat ini sedang masuk tahap krusial, yaitu implementasi dan integrasi Cbtc sistem dalam sistem persinyalannya. Karena kami mengundang para pembicara yang relevan dengan isu tersebut, di mana para pembicara tersebut adalah para pakar di dunia perkeretaapian, khususnya persinyalan, dan memiliki pengalaman yang sangat berharga untuk terutama dalam urusan implementasi dan operasi Cbtc dalam urban railway. Di sini kami mengundang Mr. Cooke, Irse Chairman, beliau sebagai Irse Chairman Singapura, juga beliau adalah Deputy Chief Specialist Signaling di LTA Singapura, dan punya pengalaman cukup luas di penerapan GOA 4 di Singapura. Ada juga Pak Yanto Yulianto dari MRT Jakarta juga memiliki segudang pengalaman berharga di integrasi dan operasi Cbtc sistem di MRT Jakarta. Terima kasih Pak Yanto. Keduanya akan dimoderatori oleh Pak Kristanto Usman yang juga tidak kalah pakarnya khususnya dalam railway safety ya. Terima kasih Pak Kris sudah menyediakan.
Terima kasih Pak Ketua. Terima kasih Pak.
Pada kesempatan ini saya juga ucapkan terima kasih kepada pihak PPI yang telah menjadi host dan sekaligus sponsor ya dalam acara webinar Irse kali ini dan juga telah mengerahkan taruna-taruninya untuk meramaikan acara ini. Terakhir saya ucapkan selamat seminar pada seluruh peserta, semoga acara berjalan lancar dan kita semua mendapatkan manfaat dan pengetahuan yang berharga dari acara ini. Terima kasih. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih Bapak atas sambutan yang sangat menarik. Marilah kita beranjak ke acara selanjutnya, acara inti webinar Irse Indonesia Section Series 4, Cbtc Integration and Operation, yang akan dimoderatori oleh Bapak Kristanto Usman. Sebelumnya, kami akan membacakan kurikulum vitae dari Bapak Kristanto Usman.
Finally, we have arrived at the main event, which will be conducted by our moderator today, webinar series Cbtc Integration and Operation, Mr. Kristanto Usman. Before we begin the main event, I would like to read several of his curriculum vitae. He was graduated from Parahyangan University, or we know that as an Unpar, in Bachelor of Engineering, in Civil Engineering, and also ITB or Bandung Institute of Technology, as in Civil Engineering, and also University of Birmingham for doctoral degree in Civil and Railway Engineering Management. He also have several experience in several BUMN, such as PT Wika Beton and PT Surveyor Indonesia. Now he is a lecturer and researcher in Unila or Universitas Lampung. Without any further ado, Mr. Kristanto Usman, time is yours.
Terima kasih MC atas introduction-nya. Terima kasih. Selamat siang. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk para peserta webinar, pengurus Irse Indonesia, dan juga para berbagai institusi yang menyempatkan hadir pada acara siang ini, dan juga para peserta dari rekan-rekan mahasiswa PPI, Madiun, dan yang lain, universitas yang lain. Saya Kristanto Usman akan mencoba menjadi moderator pada kegiatan ini. Jadi kegiatan webinar series 4 Irse ini berjudul Cbtc Integration and Operation. Jadi topik ini sangat menarik ya, apalagi terkait dengan meningkatnya pengembangan dan pembangunan yang masif urban railway di Indonesia, terutama di Jakarta. Nah, pada kesempatan ini kita akan coba melihat implementasi Cbtc Integration Operation ini yang success story ya, yang sudah atau best practice yang sudah dilakukan oleh PT MRT Jakarta. Nah, berikut ini kita akan mendengarkan paparan dari Pak Yanto Yulianto. Sebelum beliau memaparkan, izinkan saya membacakan kurikulum vitae dari Pak Yanto Yulianto. Beliau saat ini bekerja di MRT Jakarta sebagai Division Head of Information System and Technology. Sebelumnya beliau memiliki posisi juga di MRT Jakarta sebagai Department Head of Signaling, Telecommunication, and IT. Ya, responsibility untuk segala aspek signaling digital atau telecommunication, biasa kita sebut juga Sintel. Nah, kemudian sebelumnya beliau juga bekerja di komuter KCJ, kereta komuter Jakarta, dan di awal karir beliau memiliki banyak pengalaman di lingkungan PT Kereta Api Indonesia. Pendidikan Pak Yanto adalah Pak Yanto memiliki degree in Project Management di Master of Project Management dari Universitas Indonesia, Bachelor Degree di Informatic Engineering, SMIK IM Indonesia, dan juga Diploma Degree di bidang perkeretaapian. Kemudian saat ini beliau juga memegang sertifikasi dari the Institution of Engineer Indonesia (IPM) dan Institution of Railway Signal Engineer or Irse, dan juga memegang lisensi untuk Prince 2 for Project Management. Jadi untuk skill, knowledge, dan capability sudah tidak diragukan lagi. Kemudian berbagai training terkait dengan signaling dan integration. Nah, achievement beliau sudah banyak sekali proyek yang sudah di-handle oleh Pak Yanto, ya, misalnya untuk supervising kereta bandara, kemudian tim member dari Railing Wika Jasa Marga, project manager TEP-PPI Indonesia, dan berbagai proyek yang prestisius lainnya. Without further ado, we are welcoming Pak Yanto, Yulianto as a first speaker for the afternoon event. It's a great pleasure for us for having you, Pak Yanto. Please offer to you to present your presentation, please. Thank you.
Terima kasih Pak Kris. Waduh, saya nggak ngirim CV-nya, tapi kayaknya ini nyontek dari yang dipunya Pak Ahmad nih.
Siap, Pak.
Terima kasih Pak Kris. Baik, Bapak Ibu semuanya, saya mohon izin menyampaikan pengalaman kami di MRT Jakarta tentang pengalaman melakukan integration testing and commissioning di proyek fase 1 MRT Jakarta. Saya mewakili, ada Pak Arif di sini sebagai Pak Arif Rahmat sebagai project manager railway system, kemudian ada Pak Mas Raul, atur salam Pak Mas Raul, dulu ikut terlibat juga mengawal kami untuk persiapan operasinya, dan saya mewakili teman-teman lain dari MRT Jakarta yang terlibat. Jadi kami menyampaikan pengalaman. Di materi sesi ini saya tidak berani menyampaikan teori, Pak, karena kalau teori udah lebih banyak nih, ada Pak Ahmad Sugiana, ada Pak Kris, ada teman-teman Pak Rustandi, ada Pak Agung dari LRS yang lebih tahu teorinya. Mungkin kita akan coba diskusi tentang apa yang pernah kami alami, Pak. Untuk slide presentasinya, mohon dibantu. Baik. Ini sekedar berbagi pengalaman juga ke bapak-bapak di tim LRT nih, yang katanya sebentar lagi akan melakukan integration test. Dan mungkin juga nanti mohon tambahannya apabila ada yang kurang dari pengalaman teman-teman LRS waktu melakukan di KA Layang di Skytrain. Baik Pak, kita mulai slide pertama. Ya, lanjut. Ini saya tulis dengan Pak Setio juga, Pak Setio yang sekarang di Departemen Konstruksi, member Irse juga. Kami mewakili teman-teman yang lain. Yang ingin kami sampaikan, Pak, untuk sharing pengalaman bahwa sebelum ITC ini, sebelum melakukan integration testing dan commissioning, kami bersama semua stakeholder, yang kami sebut stakeholder di sini adalah dari kontraktor, dari konsultan, kemudian dari regulator, Bapak Ibu dari Dirjen KA, Bapak Ibu dari kementerian, ini yang kita sebut stakeholder. Kami duduk bersama untuk menyamakan kesepahaman dulu, Pak, bahwa goal untuk ITC ini harus sama dari masing-masing perspektif para stakeholder. Kami merefer dari kontrak masing-masing kontraktor, yang intinya bahwa ITC ini adalah untuk mendapatkan, ini saya langsung ke yang paling bawah, Pak. Intinya kita ingin mendapatkan taking over certificate untuk semua section pekerjaan, karena integration test ini adalah mencakup semua sistem, mencakup semua pekerjaan kontraktor. Jadi goal utamanya ITC ini biar kita bisa handover dari kontraktor ke project owner dengan smooth, dengan memenuhi semua kontrak dan memenuhi semua governance dari kontrak tersebut. Jadi kami definisikan bahwa ITC ini adalah mendemonstrasikan dan mengintegrasikan dengan penuh, dengan komplit semua sistem yang dibangun untuk mengecek apakah sudah memenuhi requirement, spesifikasi di lapangan yang sesungguhnya, in an operation environment. Jadi apabila pernah dilakukan tes di pabrik, yang kita sebut dengan factory acceptance test, ini beberapa parameter baru disimulasikan. Di ITC ini adalah kesempatan kita mendemonstrasikan di real environment-nya. Demikian. Jadi kita sepakati dulu di awal, kami duduk bersama bahwa goal dan definisinya adalah ini. Kami rasa ini sangat penting agar semua stakeholder punya pemahaman yang jelas dan sama. Kita lanjut. Jadi di awal paparan, saya mencoba untuk memaparkan kronologisnya apa yang kami lakukan sebelum memang dilakukan pengetesan di lapangannya, Pak. Jadi kami mempunyai beberapa tahap yang disepakati bersama, di antaranya diawali dengan installation test, kemudian PAT, partial acceptance test, kemudian S.SiT, system acceptance test, baru masuk ke integration testing and commissioning atau ITC. Setelah ITC tidak langsung take over, tidak langsung handover, tetapi ada fase trial run dulu. Untuk sisi signaling sendiri sesuai tema kita, ini penuh, komplit di semua stepping kami lakukan. Kami tandai dengan yang berwarna kuning di paparan bahwa mulai dari installation test kami lakukan, apa saja yang menjadi parameter pengetesan seperti tertuang dalam presentasi, sehingga apabila semua step ini sudah dilakukan dan mendapat sertifikat atau approval atau persetujuan untuk dilanjutkan ke step selanjutnya, baru bisa kami lakukan step kedua, ketiga, dan seterusnya. Jadi sebagaimana standar pengetesan, kami ikutin urutannya seperti yang kita lihat di paparan. Lanjut. Berikut detail persiapan dari masing-masing subsistem. Kami ambil sesuai topik yang ada kaitannya dengan signaling dan rolling stock, Bapak Ibu. Jadi bisa kita lihat, ini mohon izin apa yang kami lakukan saat itu adalah membagi beberapa kotak untuk mendetailkan apa yang harus dilakukan oleh masing-masing subsistem. Dapat dilihat bahwa rolling stock kami tes duluan. Tentunya ini setelah OCS-nya dapat dihidupkan. Kemudian dari sisi rolling stock juga menunggu signaling dan OCC-nya siap dengan timetable. Kemudian paralel dengan itu ada hubungannya dengan rolling stock juga Ph.D, platform screen door, kami tunggu kesiapannya. Dan yang paling penting radio dan data communication backbone untuk OPCA-nya harus kami pastikan dulu sebelum dapat melangkah ke tes selanjutnya. Dari sisi stasiun sendiri, tentunya di MRT ada BAS, ada Building Automation System. Kemudian dari sisi pengontrolnya, bangunan dan fasilitas-fasilitas OCC juga harus kita pastikan siap dulu. Di kotak selanjutnya kita lihat tentang persiapan depot, persiapan SCADA, persiapan beberapa mode operasi. Ini dari masukan dari tim operasi bahwa kita ada pengetesan dikhususkan untuk kondisi normal dan pengetesan dikhususkan pada saat kondisi tidak normal atau kita sebut degraded operation. Dan kami melakukan juga pada saat situasi emergensi. Setelah semua pengetesan kami jalankan untuk masing-masing subsystem, di mana kita sebut PAT, Partial Acceptance Test tadi, kemudian kita dapat melangkah ke pengetesan selanjutnya, sebagaimana yang disampaikan tadi, sehingga kita bisa masuk ke kotak yang kita tandai dengan ITC completion, Integration Testing and Commissioning completion. Ini bukan yang terakhir, karena sebagaimana di slide sebelumnya, setelah ITC tetap harus kita lakukan trial run. Di beberapa pertanyaan yang sering kami terima dengan teman-teman di Satker LRT, kami juga pernah diskusi dan paparan. Pertanyaan mendasar adalah mungkin jadi pertanyaan kita, berapa lama waktu di masing-masing step? Kita lihat slide selanjutnya, Bapak Ibu. Berikut mohon izin, ini hanya sekedar ringkasan dari apa yang terjadi dan kami siapkan di MRT Jakarta pada tahun 2018 sampai 2019. Untuk kondisi ideal, ini mungkin nanti dari ada dari teman-teman Pak Ahmad atau mungkin dari pengalaman Pak Agung, teman-teman dari LRS, ada yang lebih ideal mungkin dari steppingnya. Kami menyampaikan ini yang kami lakukan di MRT Jakarta. Langkah-langkah pengetesan yang termasuk ITC tadi, kami lakukan kurang lebih 1,5 tahun. Yang kami highlight di sini adalah di project lajimnya start to finish yang terjadi di MRT Jakarta, apa yang kita sebut finish to start terjadi di akhir-akhir project. Jadi kami harus melakukan completion of the work itu di bulan 5 2019. Sehingga kami harus menarik mundur ke belakang, membagi waktu untuk setiap step sehingga tidak dilewat. Yang terjadi adalah di project management kami harus memikirkan mana yang bisa dilakukan secara paralel dan mana yang tetap harus serial atau sekuensial. Dilihat yang kami alami pada paparan, kami mulai dengan partial acceptance test signaling, di mana kami ingat ini pertama kali menghidupkan power on perangkat signaling. Ini paralel dengan individual test kereta. Kereta memang pernah dijalankan tanpa signaling, tetapi hanya terbatas di beberapa stasiun atau di depo saja. Kami ulangi, kereta dijalankan tanpa signaling di area depo saat itu. Setelah PAT selesai, yang pertama, kami lanjutkan PAT signaling yang kedua, paralel dengan, dapat kita lihat kalau kurang besar, OCS. OCS mulai masuk, kemudian baru di area yang hijau ini, kereta pertama melakukan trial run. Ini sudah mulai masuk di main line. Pada bulan Agustus, power sudah kami tes, baru kereta bisa naik ke main line. Dan di sini belum masuk ke pengetesan bersama antara signaling dan kereta. Jadi masih masing-masing. Baru mulai pada kotak coklat di bulan 9 dan 11, kami memulai partial ITC dengan 2 kereta di awal. Ini mulai terjadi pengecekan parameter-parameter kereta, parameter-parameter signaling yang ada di rolling stock, dan sebaliknya. Bergulir ke langkah selanjutnya, kami mulai mengetes kereta-kereta lainnya dengan parameter yang udah diuji coba pada kereta ke-1 dan ke-2. Full trial run sendiri, kalau di jadwal ini, yang kami jadwalkan adalah sekitar 1,5 bulan. Tapi waktu itu kejadiannya mungkin lebih panjang, kami bisa mendapat slot waktu lebih panjang trial run ini. Nah, yang ingin kami share dari slide presentasi ini, Bapak Ibu, mungkin pengalaman kami yang kekeh atau tetap mengikuti steppingnya. Meskipun kami mempunyai waktu terbatas, tetapi semua step yang disyaratkan di perencanaan tadi, harus ada PAT, harus ada SAT terlebih dahulu, kemudian baru dilanjutkan ITC, kemudian diakhiri dengan trial run, itu kami lalui semuanya, meskipun ada beberapa waktu yang kami atur untuk di-overlapkan atau diparalelkan. Di slide selanjutnya, pada saat menyusun perencanaan, ini yang kami lakukan. Jadi ada beberapa consideration dan possibilities yang kami bahas dengan detail. Saat itu Pak Arif Rahmat sangat concern mengenai apa yang akan terjadi dan apa mitigasinya, kurang lebih demikian. Sehingga apabila terjadi extension of time, itu sudah kita prediksi di awal. Apa saja yang akan menyebabkan extension of time. Beberapa yang kami sepakati waktu itu untuk semua stakeholder, yaitu bahwa kami sadari bahwa signaling test ini mungkin menemukan beberapa hal yang perlu dilakukan tes ulang. Test may take longer than indicated. Jadi perencanaan yang tadi kami sadari mungkin ini apabila setelah dites terjadi hal yang harus diulang, kami sepakat untuk diulang. Terutama untuk hal-hal yang menyangkut safety, stopping akurasi, undershoot, overlap, dan lain sebagainya, ini kami sepakati di awal. Kalau ini terjadi dan perlu diulang, kita akan ulang. Meskipun akan menyebabkan extension of time. Tapi mungkin kembali ke filosofi dari signaling, ya safety is everything, safety first. Kami sangat menjaga untuk tidak mengskip beberapa pengetesan yang terkait, terutama yang terkait dengan safety. Kemudian dari sisi rolling stock sendiri, untuk kereta pertama yang kami tes dengan signaling, mereka masing-masing punya concern untuk mengetes semua keretanya. Maksud saya, vendor kereta mempunyai concern ingin mempunyai slot waktu mengetes semua keretanya, bukan sampling, bukan di random. Tetapi dengan keterbatasan waktu, kita harus sepakati bahwa harus ada harus ada, bukan dikorbankan ya, harus ada disimpulkan bersama bahwa keretanya dapat dirandom untuk dites. Kami hanya mempunyai 14 kereta saat itu, tapi kami putuskan urutannya bukan dari kereta 1, 2, 3, 4, dan seterusnya, tapi kami random. Kereta yang nomor berapa dulu yang akan kita tes dahulu untuk mengambil sampling dari 14 kereta itu. Kemudian yang ketiga, signaling Cbtc sendiri, ini kami sadari pasti memerlukan adjustment. Baik itu adjustment di sisi signaling, atau di sisi parameter-parameter signaling yang kita simpan di rolling stock. Misal untuk braking curve, atau untuk accelerate dan decelerate dari ATO sistem yang kita benamkan di sistem rolling stock, itu kita sadari di awal bahwa ini mungkin akan memerlukan adjustment yang semuanya akan tergantung dari kondisi lapangan dan kondisi rolling stock itu sendiri, yang mungkin kita sadari berbeda dengan apa yang kita coba di pabrik. Jadi kami tulis bahwa all stakeholder should notice on its issue and agree to priorities on safety issue. Jadi mungkin ini Pak yang kami pelajari di awal, bahwa sebelum kita lakukan kita harus menyamakan kesepakatan dulu nih. Seperti yang kita sampaikan tadi, kita duduk satu meja, bahwa semuanya harus agree dulu bahwa prioritasnya ini untuk safety. Pada saat terjadi safety issue, baik itu di rolling stock dan di signaling, kita sadari bersama bahwa ada beberapa pengetesan yang mungkin harus kita ulang, atau ada beberapa adjustment yang harus kita lakukan, baik itu di sisi kereta maupun di sisi rolling stock. Ini yang kemarin informal kami diskusikan dengan teman-teman di tim LRT. Kalau ditanya mungkin kasarnya kemarin, siapa yang harus mengalah nih, rolling stock atau signaling? Waktu itu kami pun mengalami periode itu, Bapak Ibu. Kami tidak, sebagai project owner, kami tidak bisa memihak yang mengalah harus selalu siapa, tetapi kami diskusikan case per case, isu per isu. Jadi on edge isu kami pasti duduk bersama, dan mau nggak mau kami harus menengahi. Oh, yang ini tolong signaling yang menyesuaikan, yang ini tolong rolling stock yang menyesuaikan. Kurang lebih itu pernah kami alami, dan wajar itu akan memerlukan effort dan sedikit ketegangan urat gitu. Baik, kita lanjut. Berikut adalah beberapa consideration dan agreement yang kami highlight juga. Jadi di bulan Agustus dan September itu kita mempertimbangkan atau memutuskan apakah dapat dilakukan ITC secara paralel pada saat signaling melakukan SAT pada satu kereta, apakah dapat dilakukan pada kereta lain. Jadi untuk mempercepat waktu, jadi pada saat satu kereta lagi dites, apakah kereta yang lain boleh dites juga? Nah, itu jadi bahan isu juga. Karena biar cepat beres, ayo dong jangan cuma ngetes satu-satu aja. Tetapi dari kami, dari MRT pengennya bisa nggak dari tim kontraktor mengetes secara bersamaan 3 kereta sekaligus, kurang lebih seperti itu. Kemudian yang kedua, pada saat kereta pertama melakukan dynamic test, apakah ITC dengan signaling, dengan Ph.D dapat dilakukan secara paralel? Itu jadi beberapa pertimbangan untuk percepatan waktu juga. Dan ada juga yang menarik, apakah selama melakukan dynamic test, di pengetesan pada saat S.SiT atau pada saat dynamic test kereta pertama, apakah ada beberapa item pengetesan ITC yang dapat kita isi. Jadi ini seperti mencuri waktu gitu Pak. Kalau misalnya soal untuk checklist untuk melakukan ITC itu ada 1 sampai 10 misalnya. Apakah bisa dicicil pada saat S.SiT? Nah, ini adalah salah satu upaya yang kami lakukan untuk mengefektifkan waktu pengetesan. Lanjut, nanti kita akan sampai siapa yang harus memutuskan ini. Untuk pengetesan kereta pertama, dynamic test, ini dari sisi rolling stock. Berikut adalah beberapa item pengetesan. Kami tulis garis besarnya saja. Di dynamic test, mencoba full service brake, mencoba emergency brake, mencoba konektor. Oh, ini mungkin konektor koneksi antar kereta, kemudian mengecek beberapa perangkat persinyalan yang ada di onboard kereta, kami sebut VOBC, Vehicle Onboard Control, kemudian mengetes fungsi balis. Balis ini adalah perangkat signaling yang ditempelkan di kereta. Jadi ini adalah part dari kereta, tetapi fungsinya untuk signaling. Ini kita tes selama dynamic test. Dan termasuk interlocking, ini interlocking dalam arti sempit. Interlocking beberapa perangkat signaling yang ada di kereta, bukan interlocking dari sisi signaling. Dan pada saat dynamic test kereta pertama ini, tugas signaling kontraktor adalah menyaksikan. Kami minta ikut menyaksikan. Nah, karena ini yang take lead adalah rolling stock, signal kontraktor hanya menyaksikan. Dapat dilanjut. Kita sepakati juga di sisi Cbtc signaling pada saat melakukan pengetesan, melakukan aktual rolling stock, ini kami sadari bahwa ada beberapa parameter yang harus divalidasi ulang. Pada saat awal, pada waktu pembuatan signaling, pembuatan rolling stock, masing-masing kontraktor telah mengirimkan data dari parameter yang diminta. Sebagai contoh, misal dari signaling akan meminta ini jarak pengereman, karakter jarak pengereman dari kereta ini berapa. Kemudian dari rolling stock juga mungkin akan meminta berapa respon time dari signaling pada saat dia mengirimkan instruksi pengereman dengan ATO-nya yang dapat langsung direspon oleh braking sistemnya rolling stock. Jadi kurang lebih masing-masing pada awal pembuatan itu saling mengirim pertanyaan, parameter-parameter yang pada saat itu jadi bahan asumsi pembuatan software dan pembuatan software di signaling dan pembuatan braking system di rolling stock, kurang lebih itu. Tetapi pada saat pengetesan dengan aktual, kami sadari bahwa ini mungkin besar kemungkinan akan berbeda. Ini kami sepakati bahwa goal untuk pengetesan ITC ini adalah memvalidasi ulang semua parameter yang pernah dikirimkan. Kemudian kami sadari juga bahwa beberapa item yang belum sempat dilakukan atau perlu diulang saat FAT, saat factory acceptance test, ini perlu di-retest ulang di lapangan. Perlu dites ulang menggunakan kereta yang sebenarnya. Begitu juga untuk memvalidasi karakteristik di lapangan, solid. Slope, turunan, atau tanjakan dari sisi track yang tadinya baru hanya dimasukkan sebagai parameter, kita harus tes juga dengan kondisi sebenarnya di lapangan. Yang akan kita ambil adalah reaksi dari rolling stock dan signalingnya itu sendiri, apakah sama dengan waktu kita simulasikan di pabrikan. Lanjut. Bapak Ibu mohon maaf, ini mungkin kami sampaikan summary-nya saja, karena kalau untuk terlalu detail mungkin Bapak Ibu akan ini sudah umum dilakukan di semua pengetesan. Jadi yang ingin kami sharing adalah beberapa keputusan-keputusan atau hal yang kami ambil di lapangan sebagai pengalaman kami untuk mengikuti prosedur ini. Pengetesan kami lakukan dengan 2 rolling stock di awal. Sebagaimana yang disebutkan tadi, kami memilih random. Dari 14 kereta yang tersedia, kami tes dengan 2 parameter pengetesan yang berbeda. Kereta pertama saat itu kami uji dengan PRC. PRC itu Programmable Route Control, yaitu ATO-nya dari signaling. Jadi GPK otomatis kalau teman-teman KI menyebut. Dan yang kedua, tanpa PRC. Pada saat pengetesan, kita tidak menggunakan timetable. Pada saat pengetesan, kami juga mengetes beberapa mode. Kita coba ATO-nya, kita coba ATP-nya, kita coba restricted mode. Dan kita coba juga dengan kereta itu fungsi yang terkoneksi bukan hanya dengan signaling, tapi salah satunya percobaan akurasi stop point dan melihat responnya dari Ph.D.
Maaf Pak Yanto, ya tersisa 5 menit lagi. Mohon. Terima kasih.
Pak. Slide selanjutnya, di 5 menit terakhir, ini tidak akan kami bacakan satu-satu, Bapak Ibu. Ini kemarin yang ditanya oleh teman-teman dari LRT juga, apa saja yang dilakukan pada saat ITC. Berikut kami sampaikan. ITC kami gunakan untuk, intinya pada saat ITC kami gunakan untuk mengecek kesesuaian parameter yang dulu diasumsikan pada saat pembuatan dengan kondisi real di lapangan. Jadi pada saat pembuatan mungkin kita asumsikan ada jarak dwelling time, ada jarak antar platform dengan kereta, itu di ITC hanya bisa kami dapatkan real situation-nya. Dapat kita lihat pada foto-foto bahwa masinis tetap ada, meskipun kita gunakan ETO system. Kemudian dari masing-masing kontraktor membawa alat ukurnya masing-masing. Dari sisi kereta mempunyai alat ukur sendiri, dari sisi signaling mempunyai alat ukur sendiri. Lanjut. Ini kami lakukan dengan beberapa mode. Yang nampak di layar adalah apa yang kami lakukan pada saat signaling degraded mode. Jadi pada saat ATO-nya kita anggap tidak berjalan, itu kita sebut degraded mode. Kemudian pada saat degraded mode pun tidak jalan, masuk ke emergency mode. Ini kami coba juga. Yang menarik dari pengalaman kami adalah masing-masing kontraktor akan mengcapture data. Contoh, pada saat signaling mengambil data bahwa speed yang terbaca oleh signaling adalah 80 km per jam, di titik yang sama terjadi ketidaksesuaian pembacaan dari sisi rolling stock. Nah, tentu ini akan menjadi parameter yang merubah karakteristik pengereman. Ini wajar terjadi, jadi ada dua alat ukur yang mengukur objek yang sama, tetapi hasilnya beda. Nah, di sini yang memerlukan kita duduk bersama lagi, kira-kira yang benar yang mana nih? Itu yang kami lakukan adalah melakukan fine tune atau adjustment dan mengambil sampling sebanyak-banyaknya. Agar distorsi data ini antara signaling dan rolling stock dapat kita ketahui terjadinya di stasiun mana, terjadinya di titik mana, dan ternyata siapa yang harus melakukan fine tune. Jadi ini beberapa pengalaman yang hanya kami dapat pada saat ITC. Masa di titik yang sama dengan kereta yang sama, ukuran kecepatan saja bisa berbeda. Lanjut. Berikut halaman yang paling penting menurut saya yang ingin kami share. Ini kita lihat Pak Arif mendampingi Pak Menteri, mendampingi Pak Dirjen. Ini di awal kita harus ada agreement, Pak. Apa saja pengetesan yang harus, yang wajib di-witness, disaksikan oleh para pemangku regulasi yang akan mengeluarkan izin. Jadi kami di awal duduk satu meja dulu, Pak, untuk tahapan pengetesan mana saja Bapak yang diminta untuk ikut, termasuk sampai ke Pak Menteri, gitu kurang lebih. Ini sebagai upaya dari sisi project management mungkin, agar ada beberapa pengetesan yang krusial, Bapak-Bapak regulator yang akan mengeluarkan izin operasi itu ikut terlibat dan merasakan sendiri, meskipun ini tidak kami expose. Kita lihat bahwa di meeting awal kita dengan tim balai dari Dirjen KA, kemudian dengan dari Dishub, DKI kami libatkan, dengan Pemprov DKI kami libatkan, sampai kami selalu informasikan untuk beberapa pengetesan yang kritikal, sampai ke Bapak Dirjen, ke Bapak Menteri pun ikut. Nah, ini yang kami rasakan bahwa ini menjadi booster untuk regulator dapat dengan yakin memberikan izin operasi. Karena ikut dilibatkan sejak awal. Meskipun ada beberapa pengetesan juga yang kami serahkan. Ini kami sebagai project owner sendiri MRT tidak perlu menyaksikan. Karena saking banyaknya urutan pengetesan, kami mempercayakan bahwa ini silahkan dilakukan dan di-witnessing oleh konsultan, atau bahkan hanya dilakukan oleh kontraktor, kami hanya menerima reportnya saja. Jadi Bapak Ibu yang ingin saya sampaikan di slide ini adalah bahwa agreement perencanaan ini kami set sejak awal untuk mengakomodir agar tidak terjadi dispute di akhir, agar tidak terjadi perdebatan di akhir. Misalnya untuk pengetesan signaling, kami sampai harus selalu melaporkan sampai ke Dirjen, karena ingin agar izin operasi, izin safety itu dapat keluar dengan keyakinan yang penuh dari Bapak Ibu di Balai Pengujian DJKA, karena beliau-beliau ikut dilibatkan dan menyaksikan langsung. Slide terakhir. Berikut yang kami tulis dari dari pengalaman yang kami alami selama ITC di fase 1 MRT Jakarta, bahwa selama beberapa periode pengetesan ini tidak dipungkiri bahwa akan terjadi perbedaan parameter antara yang sudah di-state pada desain dengan yang terjadi di lapangan. There will be a quite number of the tests which may have to be repeat. Kita tidak pungkiri juga bahwa ada beberapa pengetesan yang harus diulang. Dan apabila ini minor, kita sepakati bahwa ini diulang nanti pada saat operasi telah dilakukan. Jadi Bapak Ibu sedikit rahasia, kami setelah operasi komersial juga masih melakukan pengetesan. Tetapi kami pastikan itu adalah pengetesan yang minor, pengetesan yang tidak terkait dengan safety. Misalnya, telah kami paparkan juga dalam beberapa forum di internasional, kami mengalami case stopping akurasi di beberapa stasiun setelah dioperasikan, setelah komersial operasi, ternyata berbeda, ternyata meleset. Jadi kami tidak pungkiri bahwa fine tune itu terus harus kita lakukan meskipun sudah dilakukan commercial operation. Kemudian perbaikan, rectification work may be necessary not only for signaling system but also for rolling stock and other EM equipment. Setelah dilakukan ITC dan trial run, ini yang tadi kami sampaikan bahwa kita kadang-kadang harus jadi wasit nih. Rectification ini harus dilakukan oleh sisi mana? Rolling stock kah atau signaling kah? Ini isu per isu akan didetailkan oleh komite ITC board yang akan mendetailkan. Dan tugas ITC board ini yang harus memberi batas waktu pada siapa yang harus melakukan apa, kapan ini harus selesai. Yang terakhir, Pak, meskipun Cbtc signaling rolling stock ini sudah melalui beberapa pengetesan, ada beberapa yang dapat kita lakukan secara paralel. Meskipun sudah dilakukan pengetesan, mungkin akan ada behavior yang berbeda setelah commercial operation. Nah, ini akan jadi sekresi atau akan jadi keputusan yang akan mengeluarkan izin operasi. Apakah kita akan memundurkan waktu operasi komersial, atau pengetesan yang tertunda ini dapat dilakukan setelah operasi komersial dijalankan, seperti yang saya sampaikan tadi. Ini balik lagi ke target operasinya, apakah sudah dipatok atau dibebaskan seselesainya. Mungkin demikian kurang lebih Bapak Ibu, Pak Moderator.
Ya.
Mudah-mudahan belum terlalu jauh. Terima kasih.
Iya. Oke. Terima kasih sekali Pak Yanto, luar biasa presentasinya dengan peserta yang 356 peserta attendance sampai saat ini. Ini kalau bahasa anak sekarang mungkin diskusinya bakal daging semua ini. Penjelasannya juga begitu. Jadi saya rasa tadi secara kalau saya bisa summary secara overall, ya, Pak Yanto izin, itu tadi Pak Yanto bisa bahas masalah prosedur tahapan bagaimana MRT Jakarta dengan sangat detail melakukan proses pre-operation untuk signaling and rolling stock ya. Jadi bagaimana mengintegrasikan antara Cbtc signaling system dengan rolling stock dan termasuk dengan Ph.D.-nya. Dan itu sangat menarik bagaimana MRT Jakarta sudah menerapkan istilahnya proses project management itu sendiri embedded dalam satu pengetesan ini. Jadi semua hal sudah diperhitungkan, dicoba dan tadi saya juga ada hal menarik bagaimana tim Pak Yanto melakukan berbagai mode untuk kondisi bukannya normal tapi juga degraded dan yang emergency. Dan yang poin yang sangat menarik juga bahwa headway untuk close headway sampai 3 menit itu sebenarnya sudah mendekati yang dilakukan di London. Di London Underground misalnya Elizabeth Line yang akan dioperasikan oleh Crossrail nanti itu 2,5 menit ya. Jadi sebenarnya sudah mendekati. Jadi kualitas MRT Jakarta sebenarnya juga sudah harus direcord sebagai satu sistem yang internationally renowned ya. Oke, terima kasih Pak Yanto. Izin nanti mungkin setelah ini kita dengarkan dulu pembicara selanjutnya dari Robert Cooke dari LTA Singapura. Setelah itu kemudian kita lanjutkan question and answer untuk pemateri pertama Pak Yanto dan Robert Cooke. Ya, terima kasih Pak Yanto. Ya, untuk selanjutnya bila Mr. Robert Cooke has been attended this webinar. Okay, well, welcome, Robert.
Hello, everyone.
Yeah, hello. Yeah, it's we are delighted for having you to join this seminar. It's a great pleasure for us. Okay, hello, everyone. I would like to introduce Robert Cooke. He will be deliver presentation about the GOR4, and before his presentation, I would like to read and pass information about Robert. Robert Cooke is his destination now is about the Deputy Chief Specialist Signaling for LTA, Land Transport Authority Singapore. Robert is a railway signaling engineer with over 31 years of experience. He started his career with London Underground on the Central Line resignaling and Jubilee Line extension projects. It's one of the most prestigious projects in the UK. And at Invensys Rail, now Siemens, he worked on the generic principle of the distant to go radio system, now deployed on London Underground Victoria Line. And after helping Invensys win the downtown line signaling contract, he moved to Singapore at the onshore technical authority for the project utilizing Cyrus communication-based train control (CBTC) configured as a driverless unattended GOR4 system. He then joined the LTA in Singapore, where he was involved in the NSUW resignaling and the new Thomson line, both which are GOR4 system. He is currently Deputy Chief Specialist Signaling with responsibility for research and development, technical advice, and professional development. He's a chartered engineer in Singapore with the IES and serve on the railway system subcommittee. He's also chartered in the UK as an IET member. He's a member of the IRSA, where he is currently a member of council, chairman of the IRSA Singapore section, as well as serving on the IRSA International Technical Committee and Metro Handbook Committee. Away from engineering, he enjoys scuba diving and dragon boat racing. Okay, it's very impressive, Robert. Without further ado, over to you. Please start your presentation. Thank you.
Yes. Hi, I'm trying to get my presentation. Can you see my presentation? It says it's paused. Hang on,
Yeah.
let me try again.
Yeah.
So I'm not sure why that didn't work.
Okay.
Let's share. Now that should work. It keeps saying my screen sharing is paused for some reason.
Otherwise, you can send the presentation file to the organizer, and we can try to display it for you.
It's too big for me to email, unfortunately.
Okay.
Can you see it? I don't know why it says it's paused.
Yeah,
I've never seen that before.
Yeah,
I have a button that says resume share, but it doesn't seem to want to work.
Yeah. Or maybe because the size of the presentation. If I may suggest,
I've shared it via Zoom before. So,
oh, okay, yeah. Okay.
I'm not just not sure why it's not working on this one. Let me come back out of the presentation.
Okay. Or one of our team said maybe you should stop first and try again.
Let's see. Do you have it set up for multiple people to share? Because it's as soon as I try and share, it comes up. It's paused.
Okay.
So I'm just wondering if there's a setting at your end.
Yeah.
I've never seen this before.
Yeah. Okay. Organizer, can you assist Robert to do a multiple sharing? Ada yang bisa bantu? Bagaimana untuk pilihan share screen-nya sudah?
No, I don't know why this isn't working. I've never had this problem. I've never had this problem before.
Okay. How about if you restarting the Zoom, for example?
Okay, if I restart Zoom, I need access to the login. Okay, I'll restart my Zoom then.
Yeah.
So I should have to.
Okay, if possible. Oke, sambil menunggu Robert untuk join lagi. Jadi materi yang dia sampaikan Robert sangat menarik tentang GOA 4. Jadi GOA sendiri adalah Grade of Automation level 4, merupakan level tertinggi saat ini untuk otomatisasi bidang railway. Jadi sangat menarik, apalagi beliau adalah praktisi dan juga pengurus Irse Singapura. Jadi ini sangat valuable. Ya, mudah-mudahan kendala teknis ini bisa kita atasi, ya, karena rata-rata semua orang teknis mudah-mudahan bisa kita selesaikan ya, maklum. Oke.
Udah kelihatan.
Ya, oke. Great, Robert. It's working. Okay. It's working. You can start.
Okay.
Okay. Thank you.
Right. Well, sorry for the technical delays, and thank you very much for this opportunity to speak to you all. I'd say what a fantastic turnout. I noticed there's over 330 people on this call. That's really good. So what am I going to talk about today? Well, really, I'm going to talk about GOA 4 and really how much it's more of a complete integrated railway system, not just a signalling system. I originally did this presentation to Transport for London earlier in the year, and it was they invited me to do a talk, and I'd seen a number of comments by London Underground engineers on LinkedIn, where they'd said, oh, we've got automatic trains. We don't need to do that much more just to make it GOA 4. And I thought, no, that's not the case. So I thought it was a good opportunity to perhaps explain to some of the people really how much more complex and how it's a complete railway system rather than just a signalling system. So this is the presentation I put together before them. I've also start off with a little bit about sort of like the background as to why GOA 4 is so important for Singapore, and in terms of how it fits in with the overall land transport policy that's been developed over the last 20 to 30 years here in Singapore. Now, for Singapore has quite a dense population in terms of the numbers of people. And certainly this is a slide really that was for my ex-UK colleagues. And this shows a small island off the south coast of England called the Isle of Wight. And it shows to get the same population density, you would have to put the entire population of Manchester, Birmingham, Sheffield and Bristol onto the Isle of Wight to get a similar population density as we have in Singapore. And we can see here that Singapore, the population is about 1.5 times that of London, and I think your population density is probably even higher from what I can understand. So once you get to these sort of population densities, you've got to have an efficient mass transit or integrated transport policy to actually keep the city working. So one of the first things that they're doing in Singapore is, and this is key really to keeping the transport system moving, is to actually limit car usage. So anyone who wants to buy a car in Singapore has to have a certificate of entitlement, and that's valid for 10 years. And the Land Transport Authority controls the issue of all these certificates. And then there's a twice monthly bidding exercise to control the numbers. Recently, with COVID, there's been a very high demand for cars. People have decided that they would rather drive my car than have to share public transport. And so the prices have gone very high. And so there's other elements to buying a car here. So you've got the cost to build the car, the manufacturing costs. We have additional registration fees, which is a progressive charge on the open market value, excise duty, goods and services tax, and then there's a surcharge or rebate scheme depending on the vehicle emissions, and then of course you've got the dealer's margin. So you've got a lot of components. And I've taken what I consider a very modest Mazda 2, 1.5 litre, and the on-the-road price in Singapore is $104,888. That's a lot of money for a small car. And then the exchange rate based on a couple of weeks ago, that's over 1.1 billion rupiah. And I looked up the price for the Mazda dealership in Indonesia. It was only 338 million. So about certainly a third, over 3 times the price a car here than it is in Indonesia. And that's the same. It was the same in London. When I did the comparison for London, and when I told people I actually own a car, they all thought I was mad, but probably am. Having bought your very expensive car here, it then costs money to use it. If you want to travel into the central business district, there's 2 zones covering the central business district. And if you want to travel on the expressways in peak hours, you're going to have to pay a variable charge. And we have these electronic road pricing gantries at the entrance to the zones. And in the car, we have our in-car unit. And so as you drive under the gantry, it deducts the money. And every vehicle has these. So the only vehicles that don't pay are public buses. Otherwise, everybody else has to pay. If you're in a taxi, your taxi charge will add the ERP to this. So it's a very expensive business buying and owning a car in Singapore.
Robert, can you do a full screen mode for the audience?
Ah, okay. I thought I was in full screen mode.
Okay, thank you.
Okay,
thank you.
Screen mode. Just one.
Okay.
Is that better?
Yeah, nice. Very clear. Okay.
Okay, that's good. Sorry about that. I thought I had to.
No worries. No worries.
That's fine. Okay. So with this, the objectives for the MRT system, which then becomes the absolute backbone of an integrated transport policy. It started off with the north, south and east west lines, and these have 6 car trains, and they cover a very wide area of the line. So the east west line starts has 2 destinations in the east, Changi Airport and Pasir Ris, and it goes right the way through the central business district and out into the western part, into the more industrial area. And then the north-south line is sort of an inverted U shape. Again, goes through the central business district, up to the north, and then back down into the western part of the industrial area. We're also building some other lines. We've got a new line coming up, the Cross Island line. That's going to provide some relief to our east-west line. It's going to be a very big line. It's going to be a 6-car system, but designed with 8-car infrastructure, so it can be expanded in about 20 or 30 years' time. All our other lines are what we call relief lines or feeder lines that basically allow these main lines to operate successfully. So they're either 3 or 4-car lines, and they're generally running parallel to the existing lines. Another thing that we must do is we must use the land efficiently. Singapore being a very, very small country, we can't just build big sprawling depots everywhere. Most of our lines are now underground. Whilst it makes them more expensive, it takes up less space. And then we use buses, and we have a couple of LRT, light rapid transit systems. These provide feeder services for the MRT system. Now, with many people priced out of cars, very many people in Singapore simply cannot afford a car. Therefore, the public transport must be very convenient and affordable. And the objective is that public transport really should be the mode of choice for everyone. And for that, we therefore must be very affordable. So what is our fully integrated transport policy? Well, it starts off with the LTA being responsible for everything that moves on land. So if it's a train, if it's a car, a taxi, a bus, bicycle, etc., if it's infrastructure that's needed for it, like the roads, the railways, the bus interchanges, we build them. Taxis, we regulate them. Bicycles, we regulate their use and set the rules. So basically, if it moves on land, it comes under the authority of the LTA. And so with that, we've been able to produce a fully integrated transport policy. And one of the key parts of this is we have a number of fully integrated transport hubs, and these provide completely integrated commuter facilities. So they're effectively a one-stop shop for people as they go about their daily lives. And so they would typically have MRT, where our 2 LRTs interconnect to the MRTs. They also have the stations there. There will be a taxi rank, air-conditioned bus interchange. Then they will have the amenities that the public wants, such as supermarkets, general retail, lots of food and beverage outlets, and then connecting these to the housing estates that surround these hubs. We've got over 200 kilometers of covered walkways that both shelter from the sun and obviously the tropical rain. And these make a very big difference to people. So we're providing the public with convenience and protection against the weather. And these hubs have become very, very popular. They're a very efficient use of land because everything's integrated on one site. So we vertically integrate everything on a relatively small footprint. And because everything's in one place, the public, and we make it so easy for the public to use, this really does encourage the public to actually use the public transport as their mode of choice. But without it, even with all this good infrastructure, unless we're having sensible ticket costs, then people still aren't going to use it. And so we are heavily subsidized. Our adult single fare, for example, to go from Changi Airport to Raffles Place, which is in the middle of the central business district, will only cost $1.91. So very, very, very cheap. And most journeys are generally shorter than this, and all our journeys are charged on a distance travel basis. So if you do a very short journey, you won't be charged very much at all. So in terms of efficient use of land space, with the expansion and additional lines that are being built, of course, one of the big things you need for any new line is a depot. And depots take up a lot of space. And so there's been a big drive to make our depots efficient. So in the east of the island, near Changi Airport, we're currently constructing a 4-in-1 integrated 3-line MRT and bus depot. So we have our east-west line on top. That's because that's an elevated line. It's already on viaduct, so the viaduct makes it easy to come into the top level. And then we have 2 lines that are in deep level tubes, and they are the Thompson East Coast line, which has the at grade depot, and then the downtown line, which has the underground depot. And then all the connections to the 2 lower ones are actually underground. So these should be ready in 2 to 3 years' time. Obviously, they're a little bit delayed because of COVID. So why GOA4? Well, for Singapore, we don't actually have a huge population, and we do have quite significant manpower shortages. So to actually get people to drive buses and trains, we do have to have a lot of foreign workers. So you'll find a lot of our bus captains are from Malaysia or from China. So it made obvious, it was a fairly obvious choice, really, that if there's a GOA4 system where we can actually run our trains without anybody driving them, that would make sense to do that, because just from the manpower shortage perspective, that becomes less of an issue. With that, that has a big impact on the whole life cost of the system. Now, the capital expenditure for a new GOA4 system is higher than a GOA2 system, because you've got to have some additional functionality. You've got to have a fully redundant signaling system. You've also got to have remote CCTV and passenger communications within the train. But overall, the whole life costs, even though you have slightly higher whole life costs for the technical equipment because there's more of it, this is more than offset by the savings in the labour by not having train operators driving the train. It also gives you greater flexibility. So the impact of staffing issues is minimized. And this was particularly useful during the pandemic. So we didn't have to keep paying lots of train operators to run a reduced service because they didn't have a job. We just simply kept some of the trains in the depot. And so this made life during the pandemic a lot easier. Our north, south and east west line isn't GOA4, so they did have they did have to manage the manpower, but all the other lines are GOA4, so they were much easier to manage. The other reason is that the technology is there. Cbtc GOA4 systems have been well established around the world. All the main suppliers are building them. And for a lot of the systems, you get full bidirectional operation, and that also provides additional functions. So if we have a train that stalls between a station because of an incident ahead, we can then just turn that train around and bring it back into the station. and we can provide shuttle services if there's a part of the line is out. So the systems that provide GeoA4 are also very flexible in terms of the service, the type of service they can provide. So all of our MRT lines that have been commissioned since 2003 are GeoA4. So all our MRT lines are now GeoA3 or GeoA4. The north-south line and the east-west line, so that's the red and the green lines, these are GeoA3. These were recently resignalled. That was a project that commenced in 2012, came into service progressively from sort of 2016 to 2018. And that's the Thales Cell-Track Cbtc system. Because of the legacy trains, we weren't able to go to GeoA4, and we didn't have a lot of the sort of like the interfaces to the power system. And so it was decided that we would keep operators on board. So they're effectively just GeoA3. So it's fully automatic, but we do have an operator on board as well. But that's mainly for emergency incidents. So our first line that was GeoA4 was the northeast line. And then that was closely followed by the circle line. And those both used the Alstom Urbelese 300 CBTC system. So that system is no longer sold. There's not that many systems in the world with it either. So. The next project that came after that was actually the downtown line, and that's the Sirius CBTC system, which is a GeoA4 system. The following system was the Thompson East Coast line, and you can see from that the northern section is open, and then we're slowly progressing southwards. So the next tranche of stations will be opening in the second half of this year, down to Marina Bay, and then we've got a couple more stages to get to the east over the next couple of years. That's the Alstom Urbelese 400 CBTC system, which is basically the updated version of the 300. The Jurong region line, which is sort of like in the industrial heartlands out in the west, that's currently under construction, and that's using the Siemens Sirius CBTC. Then the next very big project is the Cross Island line phase 1. A lot of the construction projects for that have been let. The CBTC supplier, we haven't confirmed that. We're currently going through the procurement phase for that. This is only phase 1. Phases 2 and 3 will take it down to the airport and right the way over to the west. So that's only a very small part of the line at the moment. Again, that will be GeoA4. We also have 2 light rapid transit systems, and these are used really as feeder systems. So we can see at Bukit Panjang that connects to both the downtown line and the north-south line. This was the Bombardier Innovia GeoA4 system, and it's currently being upgraded by Alstom. The reason it's being upgraded by Alstom is because Bombardier got the contract, and obviously now Bombardier, their signalling arm has been taken over by Alstom. So that's being migrated to the CityFlow 650 CBTC. That's the most appropriate system really for it to be used, because it was originally the Bombardier system, so it makes sense to upgrade that to the next generation. Then we also have the Sengkang LRT system. Now on the map, it appears to be 2 separate LRTs, but in reality, it's all one network. with a depot at Sengkang. This is going through a lot of expansion, getting extra train sets. So it's the Mitsubishi Crystal Mover system, which is quite popular with airports. We also have it at Changi Airport, although that doesn't come under our authority. And the signaling is by Kayasan. It's their fixed block distance to go GOA4 system. And probably one of the most unusual projects, we are building a cross-border LRT system between ourselves and Malaysia. This should be able to carry 10,000 passengers per hour per day. It's 4 kilometers, so it's going to be a viaduct across the Singapore Straits. Siemens have been awarded that for their train guard MT Cbtc. Again, this will be GOA4. And at each end, there'll be a fully integrated station, customs and immigration, and at our end, it'll be integrated with the Thompson line. So a question that some of my ex-colleagues from London had put on LinkedIn, which really made me put this presentation together, was once you have ATO, the move to GOA4 is simple. Well, I believe that this is a common misconception, because a GOA4 railway is a complete railway system. It's not just clever signaling. The signaling is very clever, but there's a lot more to it than just the signaling. And it has very complex interfaces. And what we have to think about is really, what is the role of the train operator? I mean, everybody thinks of the operator driving the trains from station A to station B, but that really is the fairly simple bit. They've also got to prepare the train for service in the morning, make sure that it's fully working, report any errors. In the event of emergencies or disruptions, they're going to provide passenger communication. During incidents, they're responsible for the passenger safety. If the train doesn't stop accurately, they can adjust the stopping position to line up, and this is particularly critical if you have platform screen doors, as we do at all our stations. And then if there are systems that are degraded, that they can assess with them, and they can work actually to do either change mode into restricted manual, or they can reset systems. So they can be on board to actually take care of these degraded system working. They can report failures, and they can also, one of the big roles that the member of staff is recognized for is track intrusion detection and stroke like obstacle detection. So all of these roles need to be automated or remotely operated. And I think it's quite interesting that actually ATO systems have been around for 50 years. And that's because the driving from A to B is, relatively speaking, the easy part of the job. It was then replacing the operators that then becomes the slightly harder part. So in terms of the interfaces, they're so complex, it's kind of hard to explain. When I came to Singapore, I came with Westinghouse, now part of Siemens, and I was helping to deliver the downtown line project. I knew there were going to be complicated interfaces. I underestimated them.
Itu Pak Yulianto.
Okay. So once I actually got into the project, I realized just how complex the specifications are. And this table is typically taken from a contract. This was taken from our Thompson line contract. And this shows for T252, which is the signaling ATS and Ph.D supply, all the various interfaces. So we've got power supply, the integrated supervisory and control system, maintenance management system, communications system, track work, locomotives, etc., etc. All these systems have to have their own interface specification. And I looked at one of the interface specifications for the downtown line, the project I originally came over. And by the time it was finished, it was over 600 pages long to define the interface between the signaling system and the rolling stock. And that, it wasn't even one document, it became a suite of documents that actually defined the interface. So with this in mind, the interface specifications have to be as detailed as possible to minimize the design risk. And we do need to, however, ensure that deviations can be permitted, because if both parties to an interface can actually come up with something that's better and it's easier for them, and we end up with the same functionality and potentially something that's easier to maintain or operate, then we need to be able to allow that. So, so that's a factor that we do also need to be careful with, and that's quite difficult in a contract to write. And we also need to bear in mind that different signaling suppliers have different solutions. So all the different suppliers use different speed and location sensor combinations. So we have to be very careful specifying, where the equipment should be put, etc. Otherwise, you could favor one supplier over another, and that's not something that we want to do. However, things that do need to be very carefully defined and detailed are customer-facing requirements. So, for example, where we have train-borne announcements that are triggered by the train being at a certain location, we need to ensure that those behave consistently across the system. And so for an example of that would be ensuring that as you're approaching an interchange station, that the signaling always gives the trigger for the interchange station's announcements in good time for that announcement to be made at a sort of a standard time before the train comes into the station, so that passengers know exactly that they need to prepare and that they're coming into the station. So we try and have that so that the timings are consistent across lines. So that's something we want to specify. We also have to have passenger initiated evacuations. If we've got no one on the train, then if there's an emergency, the passengers need to evacuate. So we need that procedure to be the same regardless of what train they're on. So that's something that we need to provide. And that's going to be something that's going to involve both whilst the passenger only sees the rolling stock, that is a system that involves power, rolling stock, and signaling. So it's quite a detailed requirement. And for these, because a lot of the suppliers haven't done some of the more complex GOA4 systems together, we've got the more detailed knowledge. So we have had a couple of suppliers, especially rolling stock suppliers, that haven't actually done GOA4 systems before. So so we've got that domain knowledge. So it makes sense for us to actually define it, and then that can actually help the rolling stock supplier. So what we're going to do now is look through a couple of examples in terms of some of the things that the GOA4 system specifically has to do, and look at really at the level of complexity that they have in terms of the interfacing systems that are involved. So, for example, the first thing that happens in the morning is that trains will have to be woken up. So during the night, the train is actually powered down in the depot, so we minimize power use. And then in the morning, each train in turn will be woken up. It'll go through its self-tests, and then it's declared fit for service. And that's all done remotely. So the depot ATS system is going to select which trains to wake up. That in itself is fairly complicated because we have train berths that have multiple trains in them. So it's got to get the order correct to make sure it doesn't wake up a train that's trapped behind another train. This command is then sent to the ATC on the train. That will then activate the train. That will send a command to the train to actually power its systems up. Once it powers the systems up, each system will then do its own built-in tests, and then they will handshake with each other to determine the operational capability of that train. Is it fully fit, ready for unmanned operation? Are there a few things that are fault, so it really needs to have an attendant on board, or is it in such a state that it mustn't be used? So then the depot operator can then determine whether that train should be allowed to go out into service. And then the ATS launching strategy itself has to be able to cope if a train does fail, so that it can then start waking up other trains. And the number of trains being woken is actually limited by the traction supply system. You can only have a certain number of trains powered up, otherwise you'll actually breach the power supply capacity for the depot traction DC system. So all of this has to be a signaling, rolling stock and traction interface during the design phase. Then during operation, whether it's from power up, whether it's moving around in the depot, moving around on the train and on the main line in service, a train out of service on the main line, we have what we call train readiness states, and these will then configure the train for the train systems into the correct mode. So for example, if we're in mainline service, we will have the lights on and the air conditioning both on. If we're in mainline off service, we've still got lights and aircon on, but we won't open the doors when the train comes into the station. Once the train goes into the depot, the aircon comes off. And then if the train's going through the train wash, it goes into the train wash mode, and we will close all the ventilation dampers to make sure that there's no water gets into the train. So all these have to be configured from the signaling system, knowing which mode that it should be in. Similarly, actually, if we have a train operator on board, if a train operator is on board, they then become the master. But under that circumstance, then the signaling system has to know which mode the train operator has selected. So it has to be able to cope, the signaling has to cope with being a master or being the slave in terms of the train readiness states. And so that's a fairly complicated signaling and rolling stock interface. Cope with degraded modes. So I've got a couple of examples. And the first example is adjusting the train stopping position. This is critical for us because every single one of our MRT stations has platform screen doors. Underground, they're full height. Overground on the viaducts, they're just half height. But if the train doesn't line up to within plus or minus half a meter, then the doors will not be permitted to open. So the ATP will inhibit their opening. So if we've automated and we've got no one on the board and the train stops in the wrong place, so we could say, well, okay, we can get someone on the platform to open the doors. The problem is if the doors aren't aligned, we can't actually get to the manual door open switches on the side of the train. So actually it can become very difficult to access the train doors if you've got Ph.Ds and the train is misaligned. So what we have is a jog function. And so if the train has stopped short so it's over half a metre from its stopping position. We allow that train to jog forward until it stops in the correct position. If it overshoots by more than half a metre but less than six metres, we allow the train to jog backwards. If the train has overshot by more than 6 metres, because of the impact it could have on the stopping point of a following train, we do not allow that train to jog back. Instead, we will stop. We will make an announcement that the train is going to skip to the next station, and then the train will drive to the next station. So that's the function, but clearly we try not to use it. So in fact, the target stopping point for the ATO is actually plus or minus 300. So we already have some tolerance built in. And our target is that 99.99% of trains will stop within 300 millimeters of the stopping point. So that's the ATO performance target. The ATP has a slightly more relaxed target for opening of plus or minus 500 millimeters. So that gives a bit of a tolerance between the two. And fortunately, the train stopping is actually pretty reliable. The other big area that's critical, especially if you have Ph.D.s, is safe passenger exchange. You've got no one on the train. So I remember when working at London Underground on the Central line, we had cameras all the way down the station. We had a transmitter underneath the train, and in the cab, the train operator could see right the way down the platform exactly whether everyone was clear, so that they knew when they closed the doors, no one was trapped and that it would be safe to move off. With GOA4, that isn't the case. And so you have to take a slightly different strategy. So what we find is that actually we have much longer dwell times. They're not as dynamic as a line where you've got a train operator who can actually observe the exchange. So if we have an interchange station where we know it's going to be busy, we would typically have a 45-second dwell as our design requirement. Now, the problem with the dwell time is how much of that dwell time can the passenger actually use? And so we actually split our dwell time into 3 different parts. So the first part is the time it takes to actually prove that the train is stopped and open the doors. So that's A. B is the useful passenger exchange time, and that must be long enough for the worst case passenger loading in terms of how many people you would expect to be alighting from the train, and then how many people you would expect to be then boarding the train. And then finally, we've got C, which is the time to close and lock the doors and then start the train. And typically A to C can be in the region of about 10 to 15 seconds. So if you're at 15 seconds, that means you've lost 1/3 of your dwell time that can't be used by the passengers. So this is an area where we've tried to work with suppliers to actually get the time quicker. Because a long technical time has an impact on safety. You know, the more time you can give people to get on and off the train, then ideally everyone who wants to get off has got off. Everyone who wants to get on has got on. You've reached a quiescent state where no one's moving. That's the point when you want to close the doors. However, the suppliers have not tended to innovate in this area. They just take a command to or from the Ph.D. and just stick it through their system. And so you can end up with a lot of propagation delays. So one of the things that we did to improve this was we included the platform screen door supply with the signaling contract to give full ownership of the interface to the signaling supplier. And that has been quite successful. That has brought the times down by about 3 to 4 seconds, which doesn't sound much, but certainly for our non-interchange stations, that are 28-second dwell time. It's a 10 to 15% increase in the passenger exchange time. So we're quite pleased with that. And we define in detail the expected timing of the signalling and PSDs and the train. So we give each of them budgets to work to in the specification. The other factor with PSDs and train doors is the entrapment risk. And so we try to reduce the distance between the train door and the PSD. So both the profile of the train and the PSD affects this gap. And the PSD setting has to respect the PSD deflection limit to avoid hitting the train, or be hit by the train rather. Now, we have slab track, and now this allows the kinematic profile of the train to get a bit closer to the PSDs because there's no risk of track movement. And trains that have rounded profiles, so that the widest point at the waist, also reduce the entrapment risk. So you can see there, to the top diagram and picture is of our downtown line train, and you can see that it has quite a straight side, and that isn't an ideal design, because you can see that the gap does increase. Whereas the train below, which is one of our circle line trains, so you know, an Alstom design, that is slightly wider. It's a slightly rounder shape, and that actually is much better for reducing the entrapment risk. And at surface stations, we've got to also consider the wind load, because if the PSD deflects slightly because of the wind, we need to ensure that if you've got any failure in the suspension on a train, that there's no risk of the train slightly leaning towards a deflected PSD and colliding with it. So we've got a PSD rolling stock signaling complex signaling interface, and in fact, we also have the track engineer as well, because it's very important to get the track lined up. Not to mention, I mean, I haven't actually really put it there, but the actual top and bottom mountings are provided by the civils when they build the station. So those also need to be put in accurately as well. So effectively, you've got about 5 different parties that need to get it right for to reduce that gap as low as possible. Further measures for PSD entrapment include providing these anti-climb devices. So we can see there that circled in yellow, that sort of like wedge-shaped part of the door, as the door closes, the step plate gets covered. So if your foot is standing on the step plate, it will then jam against the door and prevent the door from closing. And we've also got the gap fillers, which are the black and white, sorry, the black and yellow striped part. And again, that's just to reduce the gap at the waist height. So these are all things that help reduce the entrapment risk. The signalling and platform screen doors are also synchronized. So the train doors and the PSDs via the signalling are synchronized so that they both close at the same time. That's something that was also further helps to reduce. And then both the train doors and the PSD doors have obstruction detection, and they have defined and coordinated reopening and closing sequences to free trapped objects and passengers. And so eventually, if someone doesn't get out of the way, the doors will then just push against them, an alarm will get raised, and then the station staff will come down and intervene with the passenger. A couple of years ago, we had a very, very thin lady. She ran for the train, and she managed to get completely between the train and the PSD, but the anti-climb device, because she was still standing on the step plate, the anti-climb device actually saved her life because the doors couldn't close because of that. Her shoe got in the way, and as a result, the doors then reopened, and then she actually managed to get, because both the train doors and the PhDs reopened. She managed to get on the train and go safely on her journey. Had we not had the obstruction detection and the anti-climb device, I would have been a very different and unpleasant outcome. Again, the signaling can only do so much. So you have to have active station management. And so we have a number of different techniques. So the signaling system will provide information to the platform screen information system in terms of the train loading. So what we use is the loadway system on the train. So the rolling stock knows how much weight it's carrying. It passes that to the signaling system. The signaling system that then passes that to the comms system, and then that uses that information on the train information boards to actually show the train loading. So green is nice and lightly loaded. Yellow, it would be fairly well loaded, and red means it's going to be very difficult to get actually board that train. And we use this to encourage passengers to actually then move to parts of the platform where it should be easier for them to board. Now, one thing that seems to work very well in Singapore, I don't think it would work, so I don't think it would work in London, are the queue lines. So we have these queue lines by the doors so that boarding passengers can know where to wait. This gets them out of the way of the people that are getting off the train. And these really work very successfully, actually. I've been very impressed. We've got various different styles at different stations, and then they do seem to work very well, which again, it makes it an efficient alighting and boarding process, which then helps reduce the hazard. Even with all of these, we've still had some lines which is taking longer, and we're having dwell times that are longer than we'd really like. So now we're actually increasing the number of doors on the train. So our new lines now have 5 sets of biparting doors per side per car. Now, clearly, that's a big increase in capital expenditure. You've got extra PhDs, you've got extra train doors, and you've got all the extra operating expenditure for the life of the system to maintain those. But we're hoping that this should actually help to improve the situation further. So another degraded example, and in fact, this is more than degraded, really. This is more of an emergency situation. And this is when we have to evacuate a train with no operator on board. So under all circumstances, the signaling will always try and get the train to the station in an emergency. So even if someone's operated the end door detrainment device to try and open the door, if the signaling can still get the train to move, or the train is even coasting, the signaling will allow it to do that. It would rather get the train into the station than stop and unlock the door. That's the principle we apply, because it's much easier to evacuate a train in a station, even if it's slightly misaligned in the station, because you can get people straight, into the platform and away. However, if a train with an emergency stops before the station, then the signaling system will stop all trains in the evacuation zone, and it will send a request to the power system to discharge traction, because we use a third rail traction system for most of our lines. And then the door deployment, even when it's done that, is then delayed. So we allow a time for all the trains to stop and the power to be removed. And we also the signaling has to assume there's an evacuation request if the train fails to communicate to the track side. So for example, if it was a catastrophic failure within the ATC cubicle on the train, let's say the ATC cubicle has caught fire, so it can't communicate to the track side, then the track side will assume that if it can't talk to the train, that there's an evacuation in process, and will then initiate an evacuation. So for this, it means that it is very important that we have full redundancy, so that we maintain our communications to the train at all time. Critical alarms need to be sent to the operator, and in fact we'll look at that later, but they're sent by two different paths. And our default ATC state for the emergency door is actually unlock it, because if the door is under a failure is unlocked, that means that passengers can always get off. So that prevents entrapment. So this is another complicated interface, and so we have, in fact, we define this in terms of how the signaling, rolling stock, and traction power interface have to work together. So coming on to the critical alarms, so for our critical alarms, we want to make sure they're always available in the control center. So we have redundancy and diversity in the way that we transmit our alarms from the train to the control center. So all the alarms on the train are gathered together by the train integrated management system. So the train system alarms, the ATC signaling alarms, and the communication systems such as the CCTV, Tetra, etc., are all integrated into by the train integrated management system, or TIMS, into one message. That is then sent to the Tetra and to the ATC system. The ATC then sends it via redundant signaling, via both signaling paths, to the ATS system. And the critical alarms go via Tetra as well, via the communication system to the ATS. The ATS then rationalizes those into a single message, and then passes that on to the maintenance management system, and also displays it to the operator. So this means that we've got different technologies and redundancy to actually get these critical messages to the control center. Now, the reason we only did the critical alarms is because Tetra has a very limited data carrying capacity. It has enough for our critical alarms, but no more. So our normal sort of like run-of-the-mill, a bit of kit's failed, but it's redundant, so it doesn't really matter. They just go via the signaling path. So non-critical alarms go via the signaling path. Critical alarms go via signaling and Tetra. And again, this is something we also have now. I haven't actually put it on the diagram. We also have an automatic track inspection system on some trains. And so they're providing critical alarms for the power rail faults and track defects with location information that comes from the signaling system. So again, this is something where we've got signaling, rolling stock, track, and the maintenance management system all working together with an integrated system. Train wash plant interface, this is fully automated as well. So the ATS system interfaces to the wash plant. So the ATC must limit the train speed through the wash plant. The ATO needs to stop the train accurately within the wash plant, because we have end train washing capability in the wash plant. So that can only work if the train stops in the correct place. And the ATS has to set the train up, so closing the dampers, etc. And the ATS will determine from the timetable whether or not that train should actually having a wash. So you may have a daily wash where you just drive straight through, no stopping, or you have a weekly wash where the train will go through, stop, and do the ends of the train as well. Now, for our surface lines, we found that anywhere in the tropics can have very sudden and very heavy and very localized rain. And we've had some incidents where that has caused problems for the braking. Now, whilst our brake rates do assume wet weather, even with a lower brake rate than we use in the tunnels, this has still caused some problems. And we've had some quite nasty overruns where trains failed to stop in the station because the track was slippery. So for our Jurong region line, which is an elevated viaduct line, each station will have a rain detector, which is dedicated to the signalling system. And with no train operators to detect the rain detectors will detect the rain, send that information to the signalling system, and then the signalling system, for a slightly wider area than that station, will then instruct trains to drive at a reduced brake rate. And so we're hoping that this should help to mitigate this. And this is really used as a support for the operator at the control center. And if the sensors aren't really working or there's problems, then the operator can also override the sensors as well. So this is a work in progress. It's not actually been implemented yet, but it is something that that Siemens are currently working on for us for the Jurong region line. Now, with all these complex interfaces, how does the operator know how to actually use the system? So what we have is what we call operating modes and principles documents. And these are detailed system operating manuals that cover all the different happy day and unhappy day scenarios. These cover the 4 core systems. And so we consider signaling system and Ph.D as one system. Then the actual passenger trains, the communication systems, so that's CCTV, customer information systems, Tetra, and then the integrated supervision and control system. Some of you may know that as SCADA. So all of these are brought together and defined in the OMPD documents. So we provide the suppliers with the skeleton manuals with all the scenarios that we would expect to be covered. And then during the design phase, the suppliers will then work together to actually populate these documents. And they cover how the system is designed, the normal operation, degraded modes, and the emergency operation of the system. And once they're complete, they're signed off by all the participating contractors. Now, interestingly, these are supposed to be how the systems come together and how it all works. In practice, as these are being written, what you find is the contractors say, hang on a minute, that doesn't work. And they kind of end up almost becoming like a desktop design review of the integrated system, even before anything's got to be tested. So whilst it's predominantly a document that's being written for the operator, it actually becomes very useful in terms as a design tool as well, because it fleshes out a lot of problems before they actually get hard coded into the design. One of the key things for GOA4 systems are the availability. You've got to have a highly available system. Otherwise, you're going to have a train sitting down in the middle of nowhere with no one on there that can intervene. So our preference is for end-to-end redundancy, so that we have spatial diversity of our ATC processors. And this is to ensure such that problems such as if you have a leak, we've had issues with air conditioning leaking. If it gets into a cubicle, It could destroy all the different lanes. So we want to have spatial diversity wherever possible. We've had systems with problems with overheating. So if a 2 out of 3 system, which is all in one cubicle, overheats, then or has water ingress, then all the lanes would be affected. So ideally, what we want is 2 out of 2 at each end of the train. However, this is very challenging for the interface in terms of the input and output circuitry, if you need redundancy there as well. So it can be very challenging for the train supplier and the signaling supplier to work together. So for example, if I've got an ATC at one end and it needs redundant inputs from the mode selector switch at the other end of the train, that's quite challenging for a train supplier to provide. So the redundancy at the train interface is something that we've been working on a lot to try and reduce some of the potential single point failures that can stop a train. Another one.
Sorry, you have 5 minutes remaining.
Okay, yeah, I've just got a couple of slides left, so almost there. Yeah. So one of the things that we're doing to help this is for testing is to increase the in-house testing capability. So each line now has its own Cbtc simulation facility. We can reproduce problems that are found in the field, and we can test the systems without resource constraints such as track access and train captains. We recently had an issue where the design of a terminal station wasn't giving us the headway that we wanted. And so we've used the Cbtc simulation facility actually to resolve the issue. And I would say it's probably saved 9 months to a year's work if we'd have had to have track access and test trains. So it's saved a huge amount of cost and effort. So very, very worthwhile. And they're used also to support operational and scenario-based training and testing so that we can improve the reaction to system faults. So they're used also to train engineers, maintainers, and operators to better understand and operate the system. So these are proving really very, very useful. And I would certainly recommend those for all new lines. We're also getting long-term service support contracts to increase the mean kilometers between failures. This means that we get locked into good relationships with our suppliers to provide spares and supports. It also enables the suppliers to commit to localize their staff. So we don't want to be having to constantly ring up Europe, etc., to get help. We want staff that are locally based that can support us. It gives us good on-call support. The reality is our maintainers are never going to have the knowledge of how a Cbtc system works compared to that of the actual supplier. And we're also getting the suppliers to provide and maintain the minimum spare holdings for the operator. So this also encourages then the suppliers to improve the high failure rate equipment. So the idea is if they're having to constantly top up the spares, they'll get fed up with that and actually re-engineer the kit to actually make it more reliable. And we also have agreed rates for extensions and additional ATC equipment for trains. Very important to us because we don't build everything at once. And so any Cbtc system, you're trapped. The problem we've had in the past is we build the initial line, you have a modest extension, it can cost 25 to 30% of the original line when it comes to the signaling, because the signaling supplier knows you've got to come to them. So we're trying to work away from it. So it's much better to have a long-term relationship with the supplier. It gives them a good work stream and it gives us better rates. So in summary, here we go. So,
multidisciplinary functions from a wide range of systems and suppliers.
So, can you hear that?
Sure.
Okay.
I can hear you. Okay.
Don't rely on suppliers to innovate where specific improvements are required. And for complex interfaces, provide guidance, especially at the supplier making use. All of this right, and the train will become the preferred mode of travel, ensuring that the roads flow freely for an effective integrated transport system. Thank you.
So, did you hear that? There was a bit of a pre-recorded text. That did you hear that? I'm not sure.
Yeah, organizer, can you
Okay.
mute the another sound than Robert?
Okay, sorry. Obviously, there was some sound. Okay, so in summary, it's complex. You've got many multi-system functions, and safety with high availability is absolutely essential for any GOA4 system to maintain passenger confidence. So, and I'll repeat again, driving from A to B is easy. It's how we respond to failures and emergencies that really defines our GOA4 system. Don't rely on supplier innovation. If you think that you need to do something new, define it, work with suppliers. And this is especially true where performance can lead to tangible benefits in terms of operations and safety. Thank you. Any questions?
Okay. Thank you very much, Robert. Very impressive and fascinating presentation. If I also conclude additional conclusion, then you have to summarize. It's the main reason is about to implementing GR4 is because to avoid formation. Singapore has two ways. First, to the ownership of the car is very high, but the second, to boost the use of the public transport, and also like Robert has said that GR4 is a fully integrated platform, very complex and very clever, but it's not easy. It should be carefully decided and adapting in the system. And also the interesting fact that the LTA has been successfully combined the Ph.D system and signaling supplier itself. It's very impressive. And also Robert said how the LTA has built the simulation facility for Cbtc and also the involvement of the local supporter to support the system. And also the system also has been proven to be safe regarding some incident regarding the Ph.D. and also the preparation of degraded system and emergency embedded at the system. Maybe that's the additional summary from me. And for the question, Robert, may I read some question
Yes.
from the audience to you?
Yes,
yeah?
certainly. Yeah.
Yeah. There are 3 questions from the audience. First from Usman Shah to Robert. In Bukit Panjang line, you said that the train automatically adjusts if the train overshoot or undershoot. So, how many meters or centimeters the tolerance of the system itself? That's the first. You would like to answer it directly or continue to another question?
No, I'll answer that.
Okay.
So actually, it's only the MRT lines that do the adjustment because they have the PSDs. So the train has to stop within plus or minus half a meter.
Half a meter. Okay.
Yeah. If it stops within plus or minus half a meter, the doors will open. If the train stops out of that range, So if it stops before the stopping position, it's allowed to jog forward as many times as it's like, because that's safe, because it's going in the same direction. If it overshoots, then as long as it hasn't gone beyond 6 meters past the position, then it's allowed to jog backwards. It's only allowed 2 attempts to jog backwards. If those 2 attempts fail, then it has to then skip and move to the next station. And then that's all integrated with the train announcement system to give announcements warning the passengers that the train's going to move in the wrong direction, or that it's going to skip and go to the next station.
Thank you very much, Robert. For the first question, it's very clear that the system has a tolerance about a half a meter, and if there is something half a meter, it can be working as well. And the second question from Chandra: if the Ph.D. door is having problem, can the train stop at the station or move to the next station? Maybe similar question, but if you have another additional answer about it.
Yes, so if the Ph.D., so for example, the main cause is that we cannot get the closed and locked signal. So if we can't get closed and locked to the signaling system, we don't permit the train to enter the platform. So, however, that operationally is very difficult. So what we do is at the end of the platform, each end of the platform, we have a Ph.D. I want to call it, it's like a lock bypass. So if the station staff can look at the Ph.D, see that all the doors are actually closed and that it's actually a failure within the closed and locked circuit, they can then send a signal to the system to say, actually, or bypass that detection, the doors are closed and locked. That will then allow the train to either enter the platform, or if the train's already in the platform, it'll allow the train to depart the platform. So we have the ability to bypass that, so that we can actually get normal movement.
I mean, the door closing is mandatory to the train to move or not to move.
Yeah.
Okay, thank you. And another question from Faisal: is it possible to integrate Cbtc system of or different Cbtc system among different manufacturers? If possible, what should be the concern? I mean, if for example, one operator would like to operate the Cbtc system, but they are planning to combine some manufacturers, is it possible? Or based on your experience? Yeah,
it's a very interesting question. So manufacturer systems aren't really compatible, but there are.
Pak Wiarco, mohon dimatikan. Yeah.
So where projects are very large, and I know there are places that have done this, such as Paris, they may specify that a new Cbtc system has to work with an existing interlocking system by a different supplier, so that they have to work together. That does make it very complex. So all our contracts are turnkey, so we only want one manufacturer per line. So we have lines that are just Alstom, lines that are just Siemens, or lines that are just Thales. But that we don't mix. So
but I mean, if they would like to be part of the system, they should choose which line they prefer to involve. Not by mean there is to reduce the complexity about the integration or mixing some of the manufacturer as well. Yeah.
So if you want to keep it simple, you really just need one supplier per line.
Okay, one supplier per line. Yeah.
Because then it's they've got the ATS system, ATC, CBI, and all that, and the track. So it's all fully integrated with their standard core design. As soon as you start mixing suppliers for different parts of the system, you've then got to define that interface. So, and we've tried to actually reduce these interfaces by we added into the Ph.D to the signaling scope. So actually that becomes, because that's quite a critical interface, because they will then go out to a subcontractor to actually to buy the Ph.D, and we insist that they come back with 2 quotes so that we can actually decide which Ph.D supplier that they will actually work with. Once we've decided that, they are then fully responsible for that subcontractor. So they're allowed to tell us which one they prefer. So they will give us a preferred one, but they will give us an alternative one as well. So it's so actually we want fewer parties working on the line, because the fewer interfaces you've got, the less complex the less complex it's become.
Okay, I agree. Okay, another question is from Prabowo Setio. It's how does LTA set a strategy to seek a new solution without relying on supplier innovation? Is there any research and development for engineering that the system research and development or any other strategy? I mean, is there any in-house R&D system, R&D department in LTA to do some innovation instead just receive any supply or innovation from the supplier?
So we don't do R&D in terms of product. What we do is we really kind of do R&D in terms of system operation.
System, okay.
So what we do is we will, and one of the things that we do is we have what we call a design for DBO, design for build and operation and manage and maintenance. And this is a process whereby we take problems. So if there's a problem with a particular system, we then say, okay, is this a generic problem? Is this something that we have to try and redesign our requirements for so that the next contract can actually design that out? And so we will work with them, and then we'll work with suppliers to say, well, what could you do in this scenario to get rid of this problem? So that's really what we do, because we don't build anything, we don't design anything ourselves. We are specifiers and then purchasers of systems. So we don't actually have any R&D for the signaling. Our only department that really does do some R&D is the FAIR systems, because they actually design some of they do their own software design, and they've got a lot of their own systems. So the FAIR systems do have R&D, but the other systems don't.
Another question about how the GOR4 system is reacted to a disastrous event. For example, when the GOR4 is operating and then the earthquake is occurring or is occurred, or the flooding, how could the GOR4 respond? Is there could it degrade the system to degraded mode and emergency, or it can be stopped immediately during the event?
Okay, so earthquakes, fortunately, Singapore is a safe area for earthquakes. Yeah. We don't. I mean, I've felt some earthquakes here that have occurred in Indonesia, but we don't actually. We're not considered vulnerable for earthquakes here. Clearly, flooding is a big issue here. I mean, we have had an incident where we had a tunnel flood because there was a problem with the drainage, and we don't actually have any sort of emergency systems really for flooding. We very much work on prevention.
Yep.
So so we have alarms, etc. If the water levels in the sumps where that give the drainage, the operator would intervene and stop the service. So that's the objective behind that.
Yeah, very interesting. I did that mechanism with Network Rail. We are building a risk-informed asset management to reduce the risk about the flooding during the operation of the Network Rail infrastructure at the time. Very interesting.
Yeah. I mean, all our, if you come to Singapore and you, a lot of people don't notice it, but you always, to our underground stations, you always go up to the station.
Okay.
So the entrance, you have steps up into the station, and that's part of a flood defense.
Flood.
Yeah,
Okay,
so actually the entrance to the station is slightly elevated over the surrounding area to try and prevent any flood water getting in. So we try and design out the risk of flooding. I mean, there are some stations that have to have emergency barriers for operators to be able to put them in, but it would be a localized event rather than a big event.
Yeah. Very interesting, because our MRT system also have experienced that kind of condition, Pak Yanto. Yeah, some flooding that may affect the operation of MRT. Okay. Another question, mungkin this is the last question for you. Okay, it's about if the one operator would like to upgrade their system from, for example, GOR2 to GOR4, is there any suggestion that should they escalate or improve to GOR3 first and then GOR4, or can be directly move to GOR4?
Okay, so what I would recommend is that you do your design for GOA4, but operate an intermediate step as GOA3.
Oh, okay.
Because even when we open a new line, we will actually open it as GOA3. We will always have for the first few months, we will always have operators on board to bed in anyway. So actually going GOA3 and GOA4, because actually GOA3 and 4, the equipment for the signaling on the train is all virtually identical. There's very little difference. The difference really is the interfaces on the track side, say to the power system and other emergency systems. That's where the degraded working, the remote controls that come into the train for GOA4. But it's easier to design them all in one go. Otherwise, you've got to come back and modify the train. So it's better to design to GOA4, but operate as GOA3 while you're still proving the GOA4 functionality.
Okay, thank you. And another question is, this could be for both of you, for Yanto and Robert. If the Cbtc system doesn't work, how is the security system for the system? Maybe for the Pak Yanto first, and then continue with Robert as well. Please, Pak Yanto.
So I don't quite understand the question in terms of security.
Yeah, the audience asks if the Cbtc system doesn't work. I mean, it doesn't work properly, or facing problem during its operation. How the system can secure the operation itself?
Oh, okay.
Yeah.
So if Cbtc fails, really that we have to suspend the service in that area. But we've got different levels of degradation. So we've got, for example, if you've got some, say, speed and sensor locations, equipment on the train, you might be able to operate in protective manual. So you might be able to put an operator on the train and still, so if you've got part of your Cbtc system on the train has failed, you may still be able to put an operator on there and drive the train manually. So we have lots of different levels of failure, and each of those levels has a predefined response. So for example, and a lot of it is depends on how you design the system in terms of the architecture. So for example, we would have an interlocking that controls 2 to 3 stations. So if you lose that interlocking, you'll have to close the service for those 2 to 3 stations, and then you can operate around it, and perhaps you'd have a manual shuttle service going through the system, or bus bridging. So we have all the different scenarios for which bit of the system has failed, and in terms of how we have to respond in terms of service recovery, and what residual service we can actually provide.
Okay.
But that's quite interesting. I mean, so for example, one of the critical locations is the operation control center. So if we lose the control center completely, we would have to close the entire line down. So for that, we have a backup operational control center. So we have 2 control centers at different locations. If the first control center, if the servers fail, but we have communications linked to the backup control center, then we'll switch to those servers at the backup control center, and the operators can stay at the control center. If, however, it's a catastrophic failure at the main control center, we would then go down to station operation, and the passenger service centers at each station can then operate the line. And generally they would just put it into headway mode just to keep the trains moving. They would define a very simple service. All the operators would then rush across town to the backup control center. And once they're there, they would then take over control from the passenger service centers and re-establish the service. So these are all the sort of techniques we use to actually to deal with different types of failure of the system. But the key thing is everything's redundant. So theoretically, we shouldn't get total CBTC failure. The radio system's redundant. All the systems on the train are redundant. All the trackside systems are redundant. So that's the key thing.
I mean, the system is safe and has a backup for the worst condition. Okay, how about the answer from Pak Yanto about this issue?
Agree with what Robert explained. Actually, many layer of security in CBTC, but maybe in easy answer, we will back to the main philosophy of signaling. If there is something failure, so the train should be in the place where the train in the safe mode, in the safe place. Jadi mungkin Pak Jawir, kalau semuanya fail, CBTC-nya down, then the CBTC will put the train in the safe position.
The safest position,
Will be we back to the philosophy fail safe. Jadi redundancy satu fail, then go to first redundancy. If the redundancy or the backup is also fail, maka kereta akan berhenti. The system will stop the train.
Okay, but I mean, because if there is some serious disruption, we can rely to this the redundancy. But if not, we will consider to fail safe, fail safe situation. Okay, very clever and very impressive. Okay. Maybe it's another. How about the organizer? Do we have? Do we still have time for another question? Hello, organizer. Okay. I think there is another question that could be answered by both Robert and Pak Yanto. Okay. Is there an axle counter as a secondary detection and aspect signal for degraded mode condition?
I saw that question. I just saw that question. I thought it was a really interesting question. Actually, it's one that we've had a lot of debate here on. And different railways take a different approach, and everyone will say, "Oh, our approach is correct." we don't have axle counters, we have track circuits.
Yeah.
Track circuit, yeah.
Yep. So there's a very strong belief amongst some of my fellow engineers that track circuits should be used to contribute to broken rail detection. And another big debate that people argue over. But that's the policy here. And so we have secondary train detection, which we use to actually find where the trains are. Now, if you have secondary train detection, it does make system recovery much quicker. It's much easier to recover when you've got secondary train detection, and it's much quicker to reinitialize a system. So that's a big advantage. Do we have aspect signals? We do. We have full bidirectional signaling, and we have signals at the entrance to every route as well. And that's really, and they're only there for degraded working. And so, for example, anyway, if you're familiar with the Palace system, normally everything is controlled by a zone controller. So if the zone controller fails, we will then fall back down to the local interlocking, and we can control the local interlocking to set some routes to get the trains moving manually. So that's one of the backups that we use there. But with full bidirectional operation, it means we have got a lot of signals. So, you know, everywhere you've got a junction, every entrance to that junction, there will be a signal because everything is fully bidirectional. All routes exist. So yes, we do have a lot of signals. I noticed there was another part to that question as well.
Yeah,
about the maintenance vehicles.
Is the maintenance vehicle equipped with all BCU and allowed to operate during commercial service hour?
So all our maintenance vehicles are equipped with ATP. And it's redundant ATP as well, so they must have redundancy on there. We don't normally put them in commercial service, so they would normally only ever go out at night. So given that our lines are relatively straightforward, they're not huge lines. We have generally we have depots at each end. We don't actually have a need to actually send them out during the day. I know networks such as London Underground, where they share engineering vehicles between lines, they will actually move engineering equipment around during the day so that it's ready. Each line has its own dedicated set of engineering, or complete suite of engineering vehicles. So there's no need to move around lines, and it would be complicated because of the ATP being different on lines anyway. So it's not. So we don't need to do that during the day. But when they do go out at night, they're fully ATP protected so that they can move at line speed. Well, it's not line speed, they can move at the maximum speed of the loco. That's how it works. And in fact, the ATS can actually detect when an engineering consist gets to site, uncouples and starts moving around, so that it makes sure that it's all kind of like coupled up and reformed and removed properly at the end of the engineering activities.
Thank you. Is there any another opinion from Pak Yanto about these issues?
Yeah, same with what explained before. Kita belum pernah menemukan menggunakan Excel counter, Pak Jatmiko. We never found in any CBTC project that use Excel counter. Then the number two, for MRTJ itself, we avoid to do maintenance during operational
during the day. Okay.
So agree with Bro.
Device-nya
sendiri, Pak, we have some kind of mobile devices that we can put it on the lorry, something like that.
For detect the problem, Okay. That's I think that's all question. We are grateful for having both of you, Robert Pak Yanto. This is a very great event, I think, with more than 300 people still stay until the end of this webinar. Those are many insights from Robert and Pak Yanto about the about both issue. Pak Yanto were explaining about the pre-operation of the hepatitis J, and Robert has been Robert has scrutinized very detailed about GR4, why we are going to use it, how to use it, and what the potential problem that can be occur during the operation. I think this is a very useful and very impressive meeting or webinar that discuss in detail about GR4, because as until this day, I just presume that GOI is just the GR4 is more advanced from GR3, but from the explanation of the Robert, it's not that it's not the the number, but the system is embedded. The whole system should be implemented as a whole, not part per part. Okay. I think that's all of the question and answer session from Robert and Pak Yanto. We are thankful about your presence and your attendance to this webinar. Okay, to offer to MC to another session, please. Yeah.
Baik, terima kasih kepada para narasumber, juga Bapak Kristanto selaku moderator pada sesi pemaparan oleh pakar dan audiensi yang dibungkus dalam diskusi yang begitu menarik. Dan sampailah kita pada penghujung acara, yaitu penutupan dan doa. Semoga acara kita hari ini bermanfaat bagi kita, negara, dan masyarakat.
Well, thank you to the speakers, Mr. Robert Cooke and Mr. Yanto Yulianto, as well as Mr. Kristanto, as the moderator and the expert presentation session, and the audience, wrapped in such an interesting discussion. Last but not least, the next agenda is closing and prayer. May our event today is beneficial for us, country, and society. Start praying. Finished. Finally, from the deepest of our heart, we do apologize for our mistakes in presenting this event. Thank you very much for your kind attention, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih Pak Yanto.
Terima
kasih Mr. Robert.
Terima kasih
Kristanto. Bagus.
Ya, Pak. Oke.
Terima kasih Pak Yanto.
Terima kasih. Thank you.
Halo Robert.
Terima kasih PPI.
Terima kasih.
Great. Okay, thank you all.
Bye.
Bye.